Okay. Yes, the thing to take note here, question 1, part 3 for the DRB is that the square here, you accidentally correction tape away. Is it? If you can get the correct final answer, it means that you must have had the square, ex square minus the square of ex, right? Okay, can now can you understand? When you see ex square, you just take this x, then you square it, and then you multiply by the bottom, correct?
Yeah.
Then you do that repeatedly for all the others, and then you add everything together. Now I need you to interpret this idea as sum of x squared multiplied by probability of x equals to little x. Does this make sense to you? Maybe I put an xi here. Then I equals 1 to in this case 16. Does it make sense? This is the general way to write out whatever you calculated for ex squared. Is it clear?
Yeah.
Because you have 1 to 16, then you just need to take xi, which is 1 square, x2, which is 2 square. That's why I have in general, it's a xi then square, where I goes from 1 until 16. Okay, this will be x1, that's x2, that's x3, so on and so forth. Then here will be the corresponding probability when x is 1. Sorry, when x1 is 1. Then the corresponding probability when x2 is 2, when x3 is 3, when x4 is 4. And then you just multiply those pairs and then you take the sum. Does this make sense to you?
Yeah.
Okay, so that's the definition of ex squared. But now what if I ask you now, totally random question, what is ex cubed? What would you do at this time? From square change to cube, what happens? Instead of 1 square times 1 over 16. Say again?
Like 1 cube.
1
over 16.
Then 2 cube times 1 over 8 plus 3 cube times 1 over 8, and then add them all together. So on and so forth. Just cube everything and then times. Cube and then times. And add everything together. Is that clear to you?
Yeah.
So now that you understand this, what if I change this into expectation of modulus of x minus 5? What do you think this means now? You see x square, then each of the x's you square it, right? You see x square here, then each of the numbers you square before you times and plus, right? Here, if you change it to x cube, it becomes cube, and then you multiply them, and then you add all of those products. So now if I change it to modulus x minus 5, what do you think you have to do?
Like I sub in the x, so it's modulus of 1 minus 5 for the first one.
Correct. Then it will be modulus 1 minus 5, which is, okay, I'll just write it in. Then the other guy will be modulus 2 minus 5. Next one will be modulus 3 minus 5. Next one will be modulus 4 minus 5. So on and so forth. You get the pattern, right? Then after that, how do you find expectation now? You take this new number, modulus 1 minus 5, which is modulus negative 4, which is positive 4, multiply by 1 over 16. Then plus modulus 2 minus 5 times 1 over 8, which is like positive 3 times 1 over 8. And then you plus modulus 3 minus 5 times 1 over 8, so on and so forth. Do you get it now?
Yeah.
In general, here is the formula you should remember. E of x, later I will also write it down for you. E of x is summation of xi times probability that random variable capital X equals to a small letter xi, where I goes from 1 to n, where n is the last number. Okay, or just all the i's. Then there's an even more general formula, which is if I now replace the x over here with f of x, what do I get? What do I mean? I need more space. I'll just zoom in a bit. What I mean if I change my x there into a f of x, what happens to my formula now? It becomes sum of not xi anymore, but rather f of xi. Okay, f of xi, and then you multiply by here, and the probability still stays the same as the original formula. Stay the same. The only thing you have to replace now is x and xi change into f of x, fxi. Is that clear to you?
Yeah.
Okay, so now you should know how to answer one of the questions in the future part with involving modulus. Okay, let me see if we'll get there eventually. Okay, let's take a look at question 2. Question 2, part 3, something wrong. You ask me, or not something wrong. You ask me what is bisymmetry in the answer key. My answer is you can just ignore it. Just ignore it. Calculate the expectation as per normal. Draw your table, upper value times lower probability. Upper value times probability, then add them all together. You'll get the same answer. Okay?
Okay.
Symmetry, it doesn't apply to all questions in general, so I don't want you to use that shortcut. It doesn't work all the time. Just do the hard work. Oh, multiply, then add them all together. Okay, moving on. Yeah, label your equation 1 and 2 and mention something like solve 1 and 2 or something similar. Or if not, it's a little bit confusing. Okay, so your part 1 is fine, 3 part 1. Now for 3 part 3, I give you the general formula now. So if we look at 3 part 3, 3 part 3, where is 3 part 3? If I can find the question paper first. Do you have it open?
Oh no. Open it now.
Okay, wait. Let me just duplicate this and send it over. Yeah, please open the file. I will try to show the question and solution as well. Okay, so yeah, here, question 3, right? We want to find part 3, find expectation of modulus x minus 4. So what should you do? What I recommend for you to do is to draw an extra row on the table, which is little x curvy x, little x modulus, little x minus 4, then take the modulus. So now we calculate each of them. 2 minus 4, -2. Modulus, +2. 3 minus 4, what would it be? -1. Take the modulus, what do you get?
1.
+1. Okay, maybe I show some working. 2 minus 4 modulus. This one is 3 minus 4 modulus. That one is 4 minus 4 modulus. That one is 5 minus 4 modulus. So what's your answer? 0 and 1. Yes?
Yeah.
So now how to find expectation of modulus x minus 4?
Multiply by the probability.
Yes, correct. So what would it be?
2
Plus 2.
times P.
Very good. Of course, you found P and Q already. Let's just look at the answer. P was 1 over 10 now. So let's just replace it with 1 over 10 and Q with 2 over 5. So instead of times P, just 1 over 10. Plus
1 times 2 over 10. Then 0 times 3 over 10. And 1 times 2/5.
Okay, good. You got it already. I don't care about the answer, just care about the method. So just create an extra row, then calculate the numbers, then pair them up. Take the sum of the products of each pair.
Okay.
This guy. All right, done. Moving on. Wrong file. This one. Yeah, so part 3 answer already. How about for part 1? Okay, here you mentioned about the random variable representing Alfred's cash. Not so accurate. You should call it Alfred's winnings. Alfred's winnings. That will make more sense. Then your working is fine. Okay. But for part 3 and 4, wait a minute. Something went wrong with part 3, is it? Okay, let's just take a look at the solution now. Okay, for part 3, find the value of x for the game to be fair. Here, all right. Honestly, to be fair, the answer key gave expectation you want it to be 0, right? Which means you want Alfred to win $0 on average. Why is that fair? I disagree with that. I think we should just cancel away this question. Just ignore this part 3. Sorry.
Okay.
Ignore this.
Why is it
about... Sorry?
Why is it not fair?
If you play a game between Alfred and Bertie, And then you want expected W. In this case, I use W instead of Z. You use Z, it's fine. Expected winnings to be equal to 0. That means that Alfred will always win no money. Is that really fair? I don't know. I think this is a bit funny. Let me get back to you on this one, part 3. For now, just ignore it.
Okay.
We move on to part 4. Now this one, find the variance of Alfred's cash after the first game. So in this case, right, when we want, you see, variance of Alfred's cash, in this case, Alfred's cash is actually now the original $100 add on the winnings. In this case, you use Z. So that's what they're expecting you to find. Okay. Z, the letter Z that I'll go back to your, okay. The Z that you use should represent the winnings. Okay, sorry, the handwriting. Winnings, Alfred's winnings. So in that case, if you find expectation of Alfred's cash, you have to take the original $100 that he started with, add on the winnings. Oh, sorry, not expectation. They asking for variance. Then what do you know about variance of a constant plus something?
Is the 100 square times variance.
Wrong. No, that's only if it's 100 multiplied by a W. Like in general, variance of A times X. This will be A squared times variance X. That's true. But that's only if it's multiplication here. Here, what's the sign? Is it times? No, it's a plus. So what do? Can you split it up? I say no. Okay, actually true, but faster way is to remember this idea that whenever you have variance of a constant plus a random variable, so that's when you have to pay attention to your handwriting. Random variable here must be capital letter. Then the A there is a constant, so must be small letter. In this case, the formula is it will always be equals to just variance of X. Throw away the A. Because what is variance? Variance is really just the square of standard deviation, right?
Yeah.
Then standard deviation, what do you understand from it conceptually? What does standard deviation mean?
Like how much the variable deviates from the mean.
From the mean, very good. Yes. So in this case, if you add on a constant to it, right, does it change the variance? The
No.
square of it. No, right? Nah, that's why you can throw it away. Adding on a constant to the data each, it doesn't change from its mean. If you plus A to every single data, the mean will also plus A. So that means that the how much you vary around the mean. If this is like for example, a horizontal line representing a mean, then the data sometimes go up, sometimes go down. If you plus A, you're just shifting the entire graph upwards. So that means that the variance still stays the same. So that's why you can throw away the A. That's how you understand it intuitively. Is this okay?
Yeah.
Yeah, that's all you need for A levels. I think the proof is not very useful. Knowing the proof is not so useful. But do you want to see the proof?
Of the variance.
Why A plus X will just become variance of X?
Can.
Okay, can. Let's go. So in this case, when we take variance of X, the shortcut, the formula, I'm gonna skip the proof. I'm not sure. I can't remember if I explained this before. This is the version of the formula you know, right? EX squared minus square EX.
You explain.
Okay. Good. Then after that, if I replace my X with A plus X, what happens? Everywhere that had A plus X, you also replace. So that means you'll get A plus X bracket square here, and minus away the square of expectation of A plus X. Now, can we just do you agree with me that expectation of A plus X, you can split it up into term by term, and it will become expectation of, I'll just write it at the side, A plus the expectation of X, and then expectation of A is nothing but just A. Is that okay?
Yeah. Can.
Can. Okay, good. Then in that case, constant, because the mean of a constant A is just A. You can think of it like this. Expectation of a constant is just taking sum of all the a's from I equals to 1 to n, then you divide by n. But a is independent of I. You see, it's not related to I. So you can factor out the a. It becomes sum of 1 times a. There's a 1 times a here. So if you factor out the a, you're left with a 1. I goes from 1 to n, divided by n. Can you tell me what's the sum of 1 from 1 to n? What does this mean? It just means
Like
you have a multiplied
multiply.
by what thing? 1 plus 1 plus 1 plus 1 until how many of these ones are there?
N.
N of them. Index I to I from 1 to n. That's how you add a constant. Summation of a constant up to n terms will have just the same constant n times. Of course, that will simply be n times 1, which is just n. Then you divide by n. What happens? N and n cancels away, you're left with a. Convinced?
Yeah.
Expectation of a is just a. Okay, memorize that. Don't need to go through this every time.
Okay.
Memorize. Constant just become a. And it's linear, meaning you have a plus sign here, you can split out into 2 terms. And also when there's a scalar, you can factor out. We'll deal with that later. So now this is just a plus expectation x. Okay, good. So now we can replace it with a plus expectation x bracket square. Okay, good. Then now here inside the a plus x square, you can also expand a square plus 2ax plus x square. And because of the linearity of expectation, there's a plus sign, so you can split out into individual terms. So expectation of a square plus expectation of 2ax plus expectation of x square. Minus away here, maybe I'll just expand it. Minus bracket a square plus 2 times a times expectation x plus expectation of x squared. Then you just expand everything. Now, what's the expectation of a squared? A is a constant. Square, does it change into a variable?
No.
No, it still stays as a constant. So expectation of a constant remains as a constant. Then you add on 2ax. Expectation 2ax. The 2a can factor out. That's because of linearity of expectation. You can factor out a 2a, just like differentiation. It's also linear. Just like integration is also linear. You can factor out a common factor. Right? Like integration, like differentiation, as an analogy. Then plus ex squared. Can't do anything to that. Then just distribute the minus. So minus a squared minus 2a ex, 2 times a times ex, plus, minus ex bracket square. Anything to cancel? Yes. This one and this one cancels. That one and that one cancels. What are you left with?
The ex square.
Ex square minus square ex. So you're back at, So you're back to the original, which is the variance of x. This is the proof, convinced?
Yeah.
Then now you memorize this. No time to prove it during exam. At least for H2, they are not testing you on proof. So
Okay.
a plus x, throw away the a. Constant doesn't affect the variance. Okay? Adding a constant or subtracting. But however, variance of ax, do you want me to show you the proof? This is a squared times variance x.
Yeah.
You want to see the proof?
Yeah.
Okay, can. Maybe I'll just continue writing. So again, variance, what is the formula? E of the thing inside square minus the square of E of the thing. Usually it's an x, but now it's upgraded to ax. Ax. So that means I also replace everywhere that had an x with ax. Is this part okay with you?
Yeah.
Ex square minus square ex becomes the x gets replaced with ax. Okay, then now we just continue expanding up. So what's ax bracket square? What's ax bracket square?
Like a square times x square.
Exactly, correct. Okay, then the next one, I can do something. A here can factor out. It becomes a times e of x bracket square. Okay, then what happens here? You see ax becomes ax bracket square becomes a square x square. what do you notice? A square is a constant coefficient of x squared. What can you do with this constant coefficient?
Oh, can take out.
Take out. So you're left with a squared in front, multiplied by e of no more a squared, ex squared. Minus away here. When you got a is a factor, e of x is also a factor. Just treat it as one variable on its own. E of x, or one variable on its own. Multiply together, then you have to square it. Bracket, square. So what do you get if you square this?
A square, then bracket ex square.
Very good. Okay, now simplify. What do you notice? Here got a squared times ex squared. Here got a squared times square of ex. Any common factor?
The a square.
The a square is a common factor. Factor that out. Then I'll just use square brackets here, I guess. Then I'm left with ex squared minus square ex, which is
The variance.
the variance. So that means the a square remains outside, but times variance of x. There we go. That's a square.
Oh.
Okay. It's because of this step here. Distribute the a square x square. Factor out the a square. Okay. Can now you see the proof one time. Pretend you just put it at the back of your mind. I know, I understand why the formula works. And just memorize for me. A times x just becomes a square. Okay. Faster lah, you must memorize. Seriously, you need to memorize one. Cannot don't memorize one. If not, you will be too slow. Okay, moving on. Okay, then this one is part 3. Did I explain this? I think I did. Then variance, yeah. Yeah, here the variance is really just don't use W lah. Use your own letter. You use Z, right? Okay, use Z. Variance of Z plus 100. Now you understand. Whenever you have a plus 100, just drop it. Change your handwriting. DROP, drop it. Then you're just left with the variance of Z. Just use your own letter. VAR, variance of Z, and then you can proceed to find it on your own. Can? I'm sure you know how to find variance of Z. Okay, and you already found it actually. It's just the answer from above. Okay, Ken. So, question 5, second part. Okay, let's read the question first for question 5. In a game, you have 2 red balls and 8 blue balls. They are placed inside a bottle. The bottle is shaken, so random. Total of 10 balls. Mary draws 3 balls at random without replacement. Also, the denominator keeps decreasing. So is this a binomial distribution?
No.
No, why?
Because it's without replacement, so the probability will change every time.
Very good, very, very good. Yes, the probability for binomial must stay the same all the time. Two outcomes, success or failure. Like for example, flipping a coin, half here and half there. You cannot flip the second coin and then the probability change. It must remain as half all the way for each trial. So over here, because it's without replacement, the probability keeps changing. The denominator will keep decreasing. So it is not a binomial distribution. Just take note of that. Don't use binomial here. The number of red balls that she draws is denoted by capital R. Find the probability distribution of R. Show that P of R more than equal 1 equals to 8 over 15. So yes, you already I think your table is fine. It's just the second part that's not clear. Show that expectation of R is 3/5. Find the variance of R. You did this already. R more than equal 1 just means this part and this part. 7 over 15 plus 1 over 15. Yeah, you got all that. 28 over 75 as well. But over here, you must understand this is very similar to the what do you call it? Normal random variables. When they have, like, for example, you have an apple and an orange that have different mass. Then they say 2 times of the apple's mass versus add on with 4 orange, or maybe the difference between their masses of 4 times of an orange versus 4 separate oranges. Then you have to go and figure out an expression for it. Have you done those kind of questions? 4 times of, let's say x1 represents mass of an apple. Then after that, you want to find the difference between this and the mass, the total mass of 4, let's say 3 separate oranges. Okay, then they call it y1, y2, y3, or maybe you plus them together in bracket. And then they say difference, so you have to take the modulus of the difference. Have you seen this kind of question?
Yeah.
Mass of orange. This is similar to this. It's similar to this style of question. And then you have to label this one as 1, 2, and 3 because you don't know whether the oranges are the same or not in terms of their mass. It's likely that they are different. Oh, so same thing over here. We want to use capital M to represent Mary's winnings, then J to represent who's the other guy? John's winning. Just a point to take note is that after Mary draws the 4 balls and you calculate how many points she has already, 4 points for each red ball, the balls are now replaced. So that means you're back to 10 balls. Okay, originally, what is it? 10 balls, then 3 of them has been drawn out, so left with 7. But the 3 balls that Mary draw, she returned back into the bottle. So now the question sort of restarts. It's like a restart. There's still 10 balls in the bottle. Then now John attempts to draw those 3 balls. Just like Mary did at the start without replacement. So then he scores 1 point for each blue ball. So how do we do this? Let's look at the solution. Here they suggested M, Mary's winnings, to be 4 times of RM, where RM represents what? RM represents the number of red balls that Mary draw.
Okay.
Okay, because each ball is awarded with 4 points, so times 4. But here for J, J will be 3 minus RJ, where RJ represents the same thing. RJ represents number of red balls drawn by John. Okay, is it red balls? Let me read again. Oh, sorry, blue balls. It's not red. I have to be a bit careful. Okay.
Okay.
Oh yes, and one more point here. Actually, let me read again. Is it blue or red? You subtract away. Does it make sense? To minus RJ, where RJ is the number of blue balls drawn. Hey, no, sorry. This is red. Oh my goodness. Still red. Okay? Because what's going on? John, what does he do? He draws 3 balls. Then 1 blue translates into 1 point plus 1 point. Here we're gonna say, let us assume that he has the maximum points was 3. Then he draws 3 balls. So let's say that he draws 0 red balls. RJ equal to 0. Then how many points should he be awarded? If he draws 0 red balls, it means that he actually drew 3 blue balls. So that means he should score 3 points. 3 minus 0 is 3. Is that okay?
Yeah.
Then now if John draw 1 red ball only, that means how many blue did he draw?
2.
Exactly, 2. So that means your score should be 3 minus 1, which is 2. Then of course the last case, if draw 2 red balls, then this will be 3 minus 2, 1 blue ball for 1. So that's why you have a 1 point. Okay, that's how they form this equation, 3 minus RJ. Okay. Now, why do they distinguish between M and J? Because they are different. They are different variables. Later on, when you calculate the variance, it will be a bit different if you make them the same. They should be different. Okay, number of the event, the random variable that represents number of red balls drawn by Mary versus the one that's drawn by John, they should be different because they are different scenarios drawn by different people. Is that okay?
Yeah.
So now we can calculate what they asked for. Find the expectation and variance of M minus J. So we can proceed to do that. So let's take a look. Expectation of M minus J, what will it be? Linearity tells us we can split it up. So E of M, E of J, respect the minus sign. Okay. Then what is E of M? Substitute the M with 4RM. So maybe here we should write down expectation of 4RM minus way expectation of 3 minus RJ. Then over here, because of the linearity, you can factor out the 4. So the 4 goes out here. Because of linearity, here you got a minus sign, you can split it up. But actually, there's an invisible pair of brackets here. So that means that this expectation 3 minus Rj, you can split up into expectation of 3 minus expectation of Rj. Is that okay?
Yeah.
Then after that, you bring back in the minus sign. So you're left with minus and then plus. Is that okay?
Yeah.
Okay, good. Then what's expectation of a constant?
The 3.
Just 3 itself. What's plus ERJ? That's when you have to think, what's the expectation of RJ? And then you realize that actually it should still be the value of the expectation of RJ should still be the same as the expectation of RM. Because the situation restart. Remember, the 3 balls were added back into the bottle.
Yeah.
So that means expectation, that means essentially in terms of calculating expectation, variance, and probability, it will still be the same. Although technically RM and RJ are different. RM and RJ are different, that is true. But when you take the expectation of RM, the expectation of RJ, they will be the same. Let me write this down. RM not equal to RJ. However, the expectation of RM, expectation of RJ, they will be the same. Likewise for variance. Is this acceptable to you?
No.
No. Oh no. Okay, let me try and convince you. This one not equal is because they are two different people. Because two different people. So you cannot assume that they are exactly the same. Two different people should be different.
Yeah.
Here it's equal. Why? Because when we are calculating expectation and variance, it's just drawing a table of the outcomes, right? The x and p, x equal to something, and then you just calculate the numbers. And in both scenarios, when Mary tries to draw versus when John tries to draw, it's the same scenario. Still 10 balls inside the bottle. Just calculation, the scenario, the numbers, okay, of balls in the bottle starts at 10. Exact same scenario. So that means when you try to calculate expectation, which means you need to draw your table, right? The x values and the p of x equal to x values, probability values, it will still be the same. So that's why expectation and variance are equal. Is this acceptable?
Yeah. Can.
Okay, you must accept this because later on when we go and deal with the oranges and apples kind of question, we have orange 1's mass, orange 2's mass, orange 3 mass. We will assume they are different, plus, plus, plus. But then later on when we try to take the expectation, we will just realize that, oh, the expectation is the same because they all follow the normal distribution with a certain mean, certain variance. Then after that, you just have to 3 times expectation of one of those 5. Oh, it will work because the expectation of y1 equals expectation of y2 equals expectation of y3. So in general, I'll just write down y to represent it. Okay, we'll get into that in the next topic. I mean, I can go through some questions later if we have time on normal distribution, that kind of question. Can So that's why, let's simplify this now. What's the expectation of RM? Oh, we calculated that already. Over here is 3/5. What's the expectation of RJ? Oh, it's just 3/5. Can? So then you just have to calculate it. Of course, at the end of the day, you just get 0. I think so. Yeah. Is it wrong? Did I do something wrongly? Let me think. Is it right? Yeah, 4 plus 4 times 5. Yeah, correct. Yeah, you will just get a. Let me calculate. 4 times 3/5 plus 1 times 3/5 gives me 5 times 3/5, which is 3, minus 3, which is 0. Yes, correct. I'll get back to 0. Okay? Can here I can replace with 3/5 and 3/5 is because ERM equals to ERJ, which is just equals to ER. This is RM actually. This guy is RM. The initial expectation did not involve John at all. So this is actually ERM. Also, you can use the 3/5 here and there. Okay, then continuing on, now let's move on to variance. So here, important point to take note, variance of m minus j is actually m plus negative 1j. Do you agree with this? M plus negative 1j?
Yeah.
Then whenever you have a sum of two, we can just assume that they are independent variables. We can split up the variance into the variance of each term. So variance of m plus variance of negative 1j. Okay, technically, let me just add one more step. This should be variance of m plus variance of negative 1j or negative j. I'll just write the negative one. Then I hope you understand why I'm writing this negative one. What happens when you have a negative one in front?
Can take out
Take out, but what do you need to do to it?
a square.
Ax, take out the a, then you have to square it. What happens when you square a negative one?
Become 1.
Become positive 1. That's the more important point. That's why over here it's a plus sign. Is this clear to you?
Yeah.
I write down one extra step in case you're confused. Variance im plus negative 1 square times variance of j. Negative 1 square become positive 1. That's why it's a plus sign. Common mistake made by students is they see minus here, they just also put down a minus here. This is not expectation. Expectation, you can do that. You see, minus stay as minus, respect the sign, fine. But for variance, it's very disrespectful. Minus become plus. Can understand?
Yeah. Okay.
This is the logic behind it. Because we factor out negative 1 and square. Okay, can, good. Now, why is this Rm and Rj so important to distinguish? It's because of this step here. When you have variance of Rm, what is it now equal to? It's variance of 4Rm. Oh, maybe I just write down a few more steps here. Equals to variance of 4Rm. Yeah, so messy. Let me just write it down at the bottom. I'll send you this file later.
Okay.
Okay. So equals to variance of m plus variance of j. But what is variance of m? Substitute the m with 4Rm. What is variance of j? Substitute the j with 3 minus Rj. Now simplify. 4 factor out, what do you get? Is it just 4 times variance Rm?
No, it's 4 square.
Or square, very good. Variance of 3 minus Rj. Can I just drop the 3?
Can.
Can, very good, because it's a constant a plus, 3 plus. Then negative 1, what happens if I factor out?
Become negative 1 square.
Very good, that's a square. That's why I can just positive 1. It becomes positive 1, that's why I can just drop the negative. Is that okay?
Yeah.
Okay, I show one more working out in case you are confused. Negative 1 square. And then after that, it becomes positive 1. Then after that, what do you get? 4 square times variance plus 1 times variance of Rm of Rj. What did I tell you about Rm and Rj's variance? They are equal, right?
Yeah.
So what's variance of Rm? It's just Mary's variance, which is the original variance that we found over here, 28 over 75. Right. Yes. This is before John was introduced, if you remember the question. So 28 over 75 times 28 over 75 here, because variance Rm is the same as variance Rj, also substitute with 28 over 75. Can?
Can.
So what you realize is you can factor out the 28 over 75, then you get 4 square plus 1 square. Now, problem here is, not problem. Here is 4 square plus 1 square. But some students, here they tell you beware of, is that they never distinguish between Rm and Rj. So what do they do now? They just substitute m with 4r, substitute j with 3 minus r without the subscript j, with a minus bracket. They open up the bracket, they get 4r minus 3 plus r. Because they never distinguish between these two r's, they add them together. What do you get?
Oh, become 5r.
So it becomes variance of, okay, I'll just simplify it straight away into 5r minus 3. What do you do when there's minus 3? Constant in a variance?
We take out the square.
Drop it. No. That's only if, sorry, you're focusing on the 5, is it? Slowly. I was focusing on the minus 3. Minus 3 can throw away. So we are left with 5r. Is that clear?
Yeah.
Constant throw away. Then now, yes, then it becomes 5 square. You take out the 5. Which is wrong, It becomes 5 square instead of 4 square plus 1 square. Very different. Okay, this is 17. That's 25. Very different,
Oh, okay.
Okay, this is wrong. This is wrong. Please don't do that. Do this instead. Okay, answer not important, whatever, let's move on. Can understand this procedure more important and when to substitute. Can, good. Next, let's take a look at what happened. Blah blah blah. Correct. Question 7. Here you missed out a possible. Okay. Do you understand? You study bio, right?
Yeah.
Then you must know the DNA codon, right?
Yeah.
ATCG, three triplet codon. How do you draw the table? Do you just draw 2 by 2 like this? do you draw your triplet codon like this? Wow, GG.
I need to draw it.
No, I mean no lah, it will be provided. But have you read it? I hope you have, and I hope that you remember how it looks. ATCG. Then what happens when you have let's say A and T now? You zoom in. Do you just draw in A, then a T, then a C, and a G? So here it's only ATA. Is that only one possibility? No, there's ATA, ATT, ATC, ATG. Correct or not? So what's the correct way to draw it if you want to introduce a third variable? You need to draw an extra line like this. I need to decrease my font size. ATCG. Very, very tiny. ATCG. Then you consider the possibilities. This will be ATA, ATT, ATC, ATG. Can you understand now?
Yeah, but I'm supposed to draw like that.
Of course, I guess you could draw it that way. So instead of just -1, -1, and -1, you're forgetting a lot of possibilities, you know. There's also -1, -1, and 0. This tree is also fine to get this way. -1, -1, then +1. First, second, and third number. You're missing out a lot of possibilities. Each box here, these 9 boxes, each of them should have 3 more possibilities. So times 3, you should have a total of 27 possibilities. Do you understand that? It's just like your DNA. How many possibilities? 4 times 4 times 4. There's redundancy because there's fewer amino acids. Right. Okay, that one I leave it to you to study on your own already. Bio. 4 times 4 times. Here it's not 4, 4, 4, it's 3 times 3 times 3. So total 27. So here, I actually recommend you realize that your probability never add up to 1, right? It's because also because of the solution, they show you a fancy way to calculate it. I feel that 27 possibilities, although it's super long-winded, just do it. Just list out every way. It's the most bull-headed, like just no thinking involved on, just manually do it. But let me show you some but I think it is the recommended strategy for you. And guaranteed to work. Just don't need to think so hard, but have to be very neat handwriting and careful. Okay, so how do you draw this table? You just think of it like this, like a tree diagram. There are 3 times 3 times 3, so you are expecting 27 rows. Please write them down in alphabetical order. By alphabetical, I mean alphabetical and numerical order. So I want to go, let's say x1, then x2, then x3. I want 3 options. So -1, then zeros, then ones. Can you see that it's 999? Because 3 times 9, 27. So you start with that. Then within, let's focus on the negative ones here. You split up into 3s, 3s, and 3s. Can you see it's small to big from top to bottom?
Yeah.
Then after that, you zoom in. Within these 3s, you split up into 3 more. So now -1, 0, 1, from small to big. Can you see that? Then likewise for the second one, small to big is -1, 0, 1. Then the next one, -1, 0, 1. Okay, I zoom out. Repeat again. 9 ways, 9 ways, 9 ways. Then within one of those 9 ways, let's focus on this one. We focus on 3, 3, and 3 ways. Go from small to big so that you will not miss out on any case. Then after that, within one of those branches, you split out into 3. -1, 0, 1. Within this other branch, -1, 0, 1. Likewise. Okay? And please don't start copying this. I'll send this to you later. You can copy after class. Then after that, you will get all these possibilities. Just go and calculate the mean for each possibility. Recommended strategy is to realize that after you do the first few rows, you should realize that there's a few unique numbers. In summary, there are only 7 cases for the values of x bar. -1, -2 third, -1 third, 0, +1 third, +2 third, +1. 7 possibilities, right? Which means that in your table, how many possibilities will there be? How many columns will there be? 7 as well, huh? 1, 2, 3, 4, 5, 6, 7. Okay. Then to calculate probability, just do the bull-headed way. Count the number of negative ones you see. 1 out of the total number of possibilities, 3 cubed, which is actually, is it 3 cubed? Let me think. 3 times 3, 9, 9, 27. Yeah. So, oh, actually, it's might be a bit more than that. This one is 1 over. Oh, right. Sorry. Yeah, you need to, after you identify each of those averages, you need to go and calculate the probability for each guy, and then you try to add them together.
Oh,
Does it make sense? So like in this case, I was actually thinking of, oh, actually there's one negative one, so it's just 1 out of 27. But that's not correct, because here the question was a bit more evil. They tell you that when it's negative 1, it's a probability of 1/4.
yeah.
So that means that actually this is negative 1, negative 1, negative 1. So it's 1/4 times 1/4 times 1/4, 1/4 cube for this guy, negative 1. Okay. And then for negative 2/3, I also, oh, by the way, I also, when I was calculating the x bar, I take the sum of these 3 numbers, x1 plus x2 plus x3, and then I divide by 3. Maybe I'll just explain how I got one of those values. Like, let's say this particular row combination of permutation of x1, x2, x3 got -1, 0, and -1. So I take -1 plus 0 plus -1. Add together, I get a -2. Then I divide by 3. That's how I get the negative 2/3 here. Likewise for the others. But I purposely arrange it such that there are those 7 unique numbers, and whenever I get one mean, I put it in the correct column. Neat and tidy. Can you see?
Okay.
And also another pattern here. Can you see? Diagonal. Just for fun only, not important. Maybe it's important. I don't know if you can see a shortcut. But basically, you can focus on those, let's say, negative 2/3. 3 possibilities, right? Then you go and calculate the probability for each one. -1, and 0. What would that be? Then after that, the second one, still 2 negative ones and 1 zeros. Then here, still 2 negative ones and 1 0. So you realize there's a shortcut. It's just 3 times of 2 copies of negative ones and 1 copy of 0. Then what's the probability for -1? I can't remember. Let me read the question. What question is this again? Question 7. Yeah, so for -1, it will be what? It will be 1/4. So over here is 1/4 inside the bracket. And then for the 0, it will be half. So half over here. Negative, maybe I'll just write this down for negative 2/3 only. Then you can try for the rest, 27 cases, just do it. I think the easiest way already. You realize that to get the negative 2/3 probability, P that x bar equals negative 2/3 is just equal to 3 times of 2 copies of -1, 1 copy of 0. But the probability of -1 is 1/4, so that's why I put a 1/4 over here in the bracket. And the probability of getting a 0 is a half, so I put on a half over there. Okay, and then you have to be careful with all the other cases. It's not that simple as just 3 times. You have to count carefully. I think it's especially for the -1/3, 0, and +1/3 cases. Okay, you have 2 separate cases. That's why you have to have 3 times of something cubed, and then 3 times this guy 1 copy, this guy 2 copies. You go and work it out on your own. Okay, yeah, then you should get the correct table. So then after that, it's just a standard question already. Just calculate the expectation and variance. Pair them up, multiply them, then you add them all together to get expectation. For variance, you need to use EX square minus square EX. So EX square, you need to take each guy, you square it. So square them first. Then after that, you start taking the paired products and add them together. Is that okay?
Yeah.
Can Okay, good. Question 7 done. No questions,
Yeah.
Here they want verify that variance x bar equal to 1/3 of x. how can you do it? You can, okay, I'll just show you the solution here. Yeah, what they did is they just draw the table and then they calculate variance of x bar using ex square minus square of ex. Here by symmetry, x bar equals 0. Forget it, just calculate it manually. You will get the 0. Oh, pair this times, pair this times, pair this times, and add them together, you'll get a 0. Then for ex squared, you have to square it, square it, square it, square it, square it, and square it, and square it first. After you get a squared answer, you multiply with the corresponding probabilities. Then you add them together, you get 1/6. Then after that, just ex squared minus square ex, and you end up with a half. For variance x, variance x, you have to recalculate it. But this time with the variable x instead of x bar. Sorry, with the variable x instead of x bar. Here, there's also a minus e x bar bracket square, but it's just a 0 square, minus 0 square. That's why they omitted it. Is that okay?
Yeah.
Okay, okay, good. Then variance x is ex square minus square ex. That one, you can calculate it. Ex square, you can calculate it on your own. E of x bracket square, this one, you can also calculate it. Here, maybe there is actually a separate table that you should keep in mind. I should draw the table for you. There's a little x values, and then there's a probability of capital X equals to little x. Take note of the difference. This is x bar, here is no bar. So we are not taking the mean now. And in this case, there are 3 possible values: -1, 0, 1, 1/4, 1/2, 1/4. Check, do these 3 values add up to 1?
Oh, yes.
Yes, okay, good. Then here, when we are calculating ex square minus square ex, the ex square here is actually asking you to get the x square, which is -1 square, +1, 0, +1. This ex square is this plus 1 times 1/4, this 0 times half, this plus 1 times 1/4, add them together. Are you clear on that?
Yeah.
You're using this table instead. Not the x bar table, okay? Not the x bar table to calculate ex square. Not the x bar table, but this table, the simpler one. Clear? Then for ex bracket square, you just find ex, pair them up, multiply, add them together, you get your ex. Then you bracket square. Okay? Can?
Yeah.
Can, make sure you know the difference, okay? X bar versus x. X bar, x and x. Know what they are asking you to find. Okay, can. All right, question 7 done. Supplementary, I haven't had time to read your solution. Let me see. What's going on? You put a tick. Okay, tick, I don't know already. Delete. Question 2, took as what do you say? Took as something matters?
I took it as the order matters. I don't know why the order
matters. Oh, okay, can. Let's read the question first. Okay, circular cut is divided into 3 sectors, 1, 2, and 3, having angles 135 degrees, 90 degrees, and 135 degrees respectively. Okay, the diagram doesn't look right, but fine. On a second circular cut, sectors scoring 1, 2, 3 have angles 180, 90, and 90 degrees respectively. See diagram. Each cut has a pointer pivoted at its center. After being set in motion, pointers come to rest independently in random positions. Find the probability that the score on each cut is 1. So what do you do? Oh, this first part is okay, is it?
Only the first part.
Okay, can. Sorry. Can. Then next one, part 2, what they ask. The score on at least one of the cuts is 3. Oh, score on at least one of the cuts is 3. So it can be 3 and not 3, not 3 then 3, or both 3, right? Then you can just calculate probability for each case. Let's see. What did they tell you? They did the complement method. At least one cut is 3 means 1 minus P of no cut at all is 3. So if none C1, circle 1, none of them is 3, the probability would be 5/8. Why? Okay, let's look at the diagram first. They have 135, 135, and 90. Okay, here's the 90, that's the 135, that's the 135 degrees. Maybe I'll just redraw it. Redraw, circle 1. And then I'm just gonna cut it down. So why do we get that 5/8 there? It's just because you don't want a 3. Where is region 3 again? Region 3 is at the bottom here. So we don't want that. That means we want this part here. Then the area of that region as a fraction of the total area is just the degrees at the center. So 90 plus 135 divided by 360. I think that's 5/8, right?
Yeah.
Yes? No?
Yeah.
Okay, 5/8. Then how about the C2 not equal to 3? Just do the same thing. Do you get that right actually? 17/32?
I don't think so. I only got the first part correct.
Okay. Let's just look at the second one. So this is circle number 2. Let's just draw that circle number 2. You have this at 180. I don't label the numbers. Very irritating. 180 degrees, 90, 90. We want which region? We want to focus on region number 3, which is this region here. Then the others are this part here. So what's the probability of not getting a 3? Means getting the purple. Must be 180 plus 90, right? On the numerator. Then divide by the total. Exactly. That should give you a 3/4. Okay. Then just 1 minus the product of these two. I think they are independent, right? They mentioned they are independent. The pointers come to rest independently in random positions. So that's why you can just multiply them. Don't need to do conditional probability or anything. All right, then you'll get your 17/32. That's part 2. Okay, good. Then next, the random variable x. The random variable x is the larger of the two scores if they are different, and there are common values if they are the same. Show that p of x equal to 2 equals to 9/32. This one just draw a table of possibilities. Table of possibilities. Table of outcomes. Do you do that? Never draw. Then try to think on your own. Not so easy. Don't recommend. Okay, here you are asking me, does the order matter? Yes, the order matters, but then wait, hold on.
Because I did it as order matters, I think it's like wrong. I mean, yeah, it's wrong.
Let me see what you did over here. You take none of the cards have 3. In this case, because it's just none, you just need to consider circle number 1 not a 3, circle number 2 not a 3, then you multiply. That's all.
Then I times 2, like.
What were you trying to calculate? Why times
2? Because I thought like the first one and second one, then the second and first one, like the sequence.
Oh, right. That's a bit specific already, because this is mean you're considering not means specifically you land on 2, circle number 1 you land on 2, circle number 2 you land on 1, then you consider the other possibility 1 and 2. Is it?
Yeah.
Wow, that's a lot of cases, right? So there's a total of how many possibilities here? 3 times 3, 9 possibilities, right? So that means the cases where you take 1 minus none of the cards have 3 would be you have to eliminate away how many cases? Let me just draw the table first. 1, 2, 3, 1, 2, 3. Clear and tidy. Then we can tell exactly what are the cases that have at least 1 3. Here, 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 here. So that means these are the possibilities that have at least one tree. You want to take one minus, so you're one minusing away these four cases. Your method should work if you calculated it correctly, the probability of these four cases. Let me see. 2 times something, 2 times something, 2 times something. There are 4 cases, but here you got 2 times, 2 times, 2 times. Oh, you have a fourth one, 2 times. A bit funny already. How come got 2 times? Probably don't need the 2 times. What are the complementary cases here? When we talk about when you want to actually list out none of the cards have trees, it means first circle followed by second circle, what does it land on? There are only these 4 possibilities, right? Can you see? Let's say circle number 1, circle number 2. It's either 1, 1, this tick here, or 1, 2, which is this tick here. We use a red tick. Or it could be 2, 1, this tick here, or 2, 2, this tick here. Right? These are the 4 possibilities where none of the cards have none of the cards have 3. Do you agree?
Yeah.
Then you have to calculate probability of each case. So let's see, 1 on the left circle number 1, 1 on the circle number 2. Maybe I put number 1 and number 2. So their positions are locked in already. Do you need to times 2 to consider both ways? Not really. Oh, let's just consider it one by one. Then what would that probability be for this 1 followed by 1? Well, we have 135 degrees divided by 360 for that circle 1. Okay, let me just draw the circle again in case you forget. 135 degrees, 135 degrees, 90 degrees. This is region 1, 3, and 2, circle number 1. Then circle number 2 is 180 degrees, 90 degrees, 90 degrees, region number 1, 2, 3, circle number 2. Then this will be what, 135 over 360 multiplied by region 1 again, so 180 over 360. Don't need to times 2. You already locked in the position. Right? These are literally the only 4 possible cases. Let's just continue. If circle number 1 lands on a 1, circle number 2 lands on a 2, that will be 135 over 360 times 90 over 360. Why times 2? I don't understand. Then 2, 1 will be 90 over 360 for the first circle times 180 over 360 for the second circle. Then finally 2, 2 will be 90 over 360 multiplied by 90 over 360. Why times 2? I don't understand. Don't need times 2. So your answer is off by a factor of 2 here.
Yeah.
Yeah, here should be a 15 over 32, right? 1 minus 15 over 32, what will you get? You will get 17 over 32, which is the answer. Yeah, so you should, if you didn't consider these times 2, your final answer here would have been 32, and then 1 minus 15 over 32 will give you your correct answer of 17 over 32. So your method works, but you counted wrongly. Okay? Yeah. All right. Let me look at the solution. There's a simpler way, which is none of the card is 3. Really, you don't need to consider all cases. It's just probability. First one is not 3, second one is not 3, then times them together. That's all. Don't need so many cases. Can lump them together. Not 3. Much faster. Okay, moving on. So now how about show that px equal to 2 is 9 over 32. Wow. Okay. So x is what? Larger of the 2 scores. So maybe I'll just draw that table here. I can copy it over. Oh, no, paste. Yes. Okay. What do we want? We want larger of the 2. So in this case, let's just list them down. If it's a tie, you'll just get the number itself. So 1, 2, 3. Then 1 versus 2, 1 versus 3, you just get the larger number, 2, 3. 2 versus 1, you get 2, 2 versus 3, you get a 3, 3 versus 1, you get 3, 3 versus 2, you get 3. Is that okay?
Yeah.
So these are the possibilities. What do they want? X equal to 2. So what are the possibilities? Here, here, and here. Right?
Yeah.
Circle 1 is a 2, circle 2 is a 1. That's exactly what they wrote down over. I think I'm in one of those cases. Circle 1 is okay. Here they are saying circle 1 is a 2, circle 2 is a 2. So they are considering this case. Maybe I'll just color code the cases. Blue color is referring to this one. Yellow color, circle 1 is 2, circle 2 is 1. Means 2 then 1. Here, yellow color. Can you see? Then the third case, circle 1 is 1, circle 2 is 2. So this case, right? If you draw a table of outcomes, oops, sorry. Oh, did you see that calculator?
No.
Oh, okay. All right. Never mind. I'm in the presentation mode. Okay. And never mind. Ignore that. Nothing. Okay. So yeah. So basically, if you draw a table of outcomes, then it will be super clear what are the cases you need to consider. Here. Oh, then you just need to calculate the probability for each one. So because they are independent events, right? Circle 1 landing on something, circle 2 landing on something, you can just multiply the probability because they are independent. So probability C1 is 2 multiplied by probability C2 is 2. It's just 1/4 times 1/4. 90 over 360, 90 over 360. Right? Remember the circle? Maybe I label the parts. This is a 1, that's a 2, that's a 3. This is 1, this is 2, this is 3. 1, 2, 3, 1, 2, 3 regions. Okay, good. So now, do you get this 1/4 square? C1 is 2. What's the probability? C1, the pointer lands on region 2. This part here. 1/4, right? 90 degrees.
Yeah.
That's why it's 1/4. For this guy is 1/4. Then how about C2 equal to 2? Probability of C2 equal to 2. Still 1/4 of a circle. So that means probability will be 1/4 as well. 90 over 360. If you really cannot remember 1/4. 90 divided by 360 will give you 1/4. Is that okay?
Yeah.
Just take the area just take a fraction of the what do you call this? The angle at the center divided by the angle 360. The angle representing the entire circle, 360. Then you will get your probability of that particular sector. Okay, then how about C1 equal to 2? Again, it's 1/4. We already calculated that. How about C2 equal to 1? This one a bit different. C2 equal to 1. Look at C2 circle. 180 over
360.
Which is the half that you have over here. And 1/4 is over there. Right? Can you understand the solution? And then the last one. I think you get it by now. C1 equal to 1 is 1/4. C2 equal to 2. Region 2 again. 90 over 360. 1/4. Then just multiply and you get your answer. 9 over 3 over 9 over 32. Can? Okay, good. Next one. Show that expectation of x is 75 over 32. Draw a table. Just draw a table. Okay? Serious. Draw a table. Won't go wrong one. X, little x. P of capital X is equal to little x. There's how many possibilities for the result? When you have circle 1 landing on something, circle 2 land on something, between the two you compare and see who is the larger of the two scores, or common if they are the same. Then these are the possibilities. So I see that there's only 1, 2, or 3. Is that okay?
Yeah.
Good. Then now we calculate the probability for each case. We already calculated probability for x equal to 2. It's 9 over 32, right? From the working before. Now we need to fill in the blank for the other cases. How? Would you recommend counting probability of the trees? Go and go through this entire procedure again, but for all 1, 2, 3, 4, 5 cases. Or is there a smarter way? You got two blanks here. Do you want to find out the blank on the right side first?
The x equals to 1 first.
Very good. X equal to 1 first. Why? Why is there a smarter choice? Look at your outcomes.
1.
Only one possibility. Don't need to work so hard to find out that probability. So to get a 1-1, what would the probability be? Let's calculate it now. Circle 1, you get region 1, 135 over 360. That's for circle 1. Then because it's an independent event now times circle 2. What is the oh, right. I get why you're multiplying by 2 already. You are considering like if you let circle 1 land first followed by circle 2 or versus circle 2 land first followed by circle 1.
Yes.
No lah, don't need. No. Just think of them as being consecutive events. And
I don't need. I cannot tell when.
Okay. Let me think a little bit. This case, do you really need to times 2? You don't actually, because the pointers, I guess you can think of them being they're fun at the same time.
Ooh.
After being set in motion, the pointers come to rest. They never specify whether the order matters or not. How to convince you that the order doesn't matter here? Let me think a bit. Wow, if the order actually does matter, how many possibilities would there be? Whoa. That's no lah. This is not this is not this is, you can think of this as an analogy for this would be flipping 2 coins. Okay, then you're trying to get the result. In that case, I think for this kind of question, the order doesn't matter as well, even if it's a case where it's flipping coins. Like if there is, there will be double the number of possibilities. Okay, for now, can you accept that the order doesn't matter?
Okay.
This question. Can okay.
Yeah.
Then we'll just calculate the probability. For the case where the order doesn't matter. Okay, can. So now for 1, what would it be? Probability. 135 out of 360, right? Then how about 1 again for the second circle?
Half.
Half, 180 over 360, which is half. Yes. So at the end of the day, what would that be? 135 over 360 times half. You get 3 over 16. So just to make things easier, I'll multiply by 2 on both sides. So 6 over 32. Then since they're both 32, I can straight away tell what's the answer for the last guy. It must be 32 minus 6 minus 9 over 32. Right?
Yeah.
Because they must add up to, sum must equal to 1. Okay? So calculate 32 minus 6 minus 9, 17 over 32. All right, so we have the table of the x values and the probability of the corresponding. Okay, we have the little x values as well as the probability that the random variable takes on that particular little x value. Then we can just calculate our expectation and variance as usual, right? They did it over here. 1 times px equal to 1, 2 times px equal to 2, 3 times px equal to 3. Blah, 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 you get 75 over 32. Then for variance x is just ex squared minus square ex. Just calculate the square version. So x squared on top, what would it be? 1 square is 1, 2 square is 4, 3 square is 9. So ex squared will be 1 times 6 over 32, 4 times 9 over 32, 9 times 17 over 32. Okay. Then after that, substitute the EX, which we already found out as 75/32, bracket square. Can?
Can.
Can, huh? Okay, good. Next. Let's go on. Did you do anything else? Question 3. Take second part, not sure. Okay. What is question 3 about? Two discrete random variables denotes the number of sixes showing when two ordinary fair dice are thrown. Tabulate the probability distribution of x. This is the case where I believe the order doesn't matter. Just think of the two dice being thrown at the same time. Okay, for this kind of question, usually the order doesn't matter, I guess. But I might have to eat my words. I'm not sure. Okay, let's just continue reading the question. Tabulate the probability distribution of x. Two dice are thrown repeatedly. Find the probability that in 5 throws, the result x equal to 2 occurs at least once. The dice are thrown n times. Find the find the least value of n such that p of x equal to 2 occurs at least once in the n throws, more than 0.9. So solve for n, the least value of n. Okay, so they got this table. Did you get the same table? Yes, yes. Okay. You have the question paper with you, right?
Yeah, but the answer key.
Oh, okay. Yeah. Okay. Can. Then for here answer key. It's on the screen. Okay. Then yeah. So what do you want to do now? After you calculate the table, second part you're not sure. Two dice are thrown repeatedly. Find the probability that in 5 throws the result x equal to 2 occurs at least once. So this is actually a binomial distribution already. I think so. Is it not? Let's think about it. Y represents, we introduce a new random variable y, not capital X. It is the random variable denoting number of throws that have 2 sixes appear out of 5 throws. Okay. So here they already described the event to you. The result x equal to 2 occurs at least once. Oh, so that means what do they want? The result x equal to 2. Maybe I should just underline this part. This is the event you are interested in, and this is the success outcome. Failure will be when x is not equal to 2. So there's an associated probability, which is this fella here. Right? 1/36.
Yeah.
Is it right? Result x equal to 2. Yeah. Probability p equals to 1/36. Then how many trials are there? How many throws are there?
5.
5 throws. So n equal to 5. We got our p, we got our n. Do we know that the throws are independent? Yes, they're just throwing dice. There's no relationship from one throw to the other. So they are also independent throws. And we have 2 outcomes, success or failure. And the probability will just, failure means x not equal to 2. Then that just means they will have a corresponding probability of 1 minus p. Okay, good. Then now we can interpret the question as finding out p. We can interpret as capital Y is a random variable that follows a binomial distribution, n value being 5, and a p value being 1/36. Is that okay?
Yeah.
Yeah, 2 dice thrown, then that's the random variable y. Find the probability that in 5 throws the result x equal to 2 occurs at least once. What does this mean? It means you want p of y more than equal once. At least once, more than equals 1, sorry. That's what they are asking you to find. Is that okay?
Yeah.
But here, p of y equal to 1 is actually just p of y equal to 1. Or y more than equal to 1 is actually p of y equals to 1, y equals to 2, plus p of y equals to 3, plus p of y equals to 4, plus p of y equals to 5 and you stop the n value. Would you want to calculate them one by one using the binomial probability table?
No.
Definitely not, because there's a faster way. 1 minus p of the opposite of more than equal 1 is
0.
strictly less than 1, which is exactly equals to 0. Okay, 1 minus p y equal to 0. Then after that, you can just sub in y equal to 0. What would that be? Just use the formula, or you can think of it as, if you really want to use logic, you can think about it as you want 0 of those x equal to 2. So that means you have failed 5 times. Failed 5 times means q equal to 1 minus p, which is 1 minus 1 over 36, which is the 35 over 36. And you fail 5 times, so you take 35 over 36 raised to the power of 5. You fail 5 consecutive times. Fail to get this result. Okay? You get our probability. Can?
Yeah.
Okay, next. The dice are thrown n times. Okay? Find the least value of n such that p of x equal to 2 occurs at least once in the n throws. So now we introduce yet another random variable. This is, I think, another binomial distribution. Let's read. W, let it be the random variable denoting the number of throws such that 2 6s appear out of n throws. Okay, here we change the 5 to an n because that's what the question asks. Oh, the dice. Oh, actually here they mentioned dice, they should also be more precise on the 2 dice. I guess it's implied because they use the plural form of the word. So they are referring to 2. Right? Die is singular, dice is plural.
Yeah.
Yeah. So that means that it's the same situation. We just change our 5 to n. How to solve this question? You want to, let's just read the first. They want least value of n so that p of x equal to 2 occurs at least once in the n throws. So that means you want this w to be more than or equals to 1, because at least once means more than equals to 1, and more than 0.9, so just copy and paste. Oh. Then how do we calculate this? It will just be 1 minus p of, this implies that this will just be 1 minus p of w exactly equal to 0 more than 0.9. Right? How do you calculate p of w equals to 0? This time, you must really use logic to calculate it. Or you can still use the binomial formula, because this is just bn comma p. In this case, p is still 1 over 36. This will eventually become 35 over 36 power n. Or you could think of it, if you really use the MF26. Let me bring up the MF26 first. MF26, where is it? MF26 over here. Let me scroll to the right page. Here, okay? Oops. You can use this formula here. Can you see?
Okay.
N choose x times p power x times 1 minus p. Here we are failing. W equal to 0 means this x here equal to 0. This n here will be just n minus 0. The x just takes on the value of 0. Okay. Is that clear? Can yeah, so we're just gonna use that. Let me just copy it down. You can ignore the other. Oh yeah, by the way, this one, Poisson and geometric, that's for further math. Please ignore it. Okay, ignore. Okay, focus only on these 3. Okay, moving on. Let me just paste it here. Okay, then we can use it. So how do you calculate p of w equals 0? You just have to sub the x with a 0. So n choose 0 times p to the power of, in this case, p we already know is 1 over 36, right? Over here.
Yeah.
So raised to the power of 0, then 35. 1 minus 1 over 36 is just 35 over 36 to the power of n minus 0, right?
Yeah.
That's how you get your 35 over 36 power n. Can? Why? N choose 0 is just what? It's just equal to 1. Few formulas you must remember. N choose 0 equals to 1. N choose 1 is equals to n. And n choose n minus 1 is equals to n. N choose n is equal to 1.
Oh.
How to remember this? Remember this diagram, Pascal's triangle, binomial expansion, binomial coefficient, Amax. These values, let's say, for example, this is actually phi choose 0, that is phi choose 1, that's phi choose 2, that's phi choose 3, phi choose 4, phi choose 5. Can you see a pattern?
Yeah.
In particular, the first two and the last two. It's just 0, 1, then 5, 4. Is that the same as this? 0, 1, and 5, 4. It's just that instead of 5 and 4, it's n and n minus 1. N is 5, n minus 1 is 4.
Yeah.
Okay. Then you can do the same for all the other rows. This is for when n is equal to 5. Huh? Okay. These first two and these first two and these last two, you need to memorize the general form. This one. Okay?
Okay.
Can?
Okay.
Can. Good. Then n choose 0 is 1. So you just get a 1 multiplied by whatever power 0 is just 1. 1 times 1, then it will give you 35 or 36 to the power of n. Yeah, then from here, you can just use GC, or you can take the logarithm to solve it. So here they try to use logarithm. Let me just show you how to solve it. Negative 35 over 36 power n. The 1 bring over, what do you get? Minus 1. No? Simplify. 0.9 minus 1 is negative 0.1. Okay? I got negative on both sides. I don't like it. So I take the I multiply by negative 1 on both sides. So I end up with the same thing, but I just remove the minus sign. What do I need to do to my inequality now?
Change the direction.
Change direction because I multiply by negative 1. By the way, the general rule for changing direction is when you are passing it through a decreasing function. So let's say, for example, you got a decreasing function like this. Okay? Here is a small x. Here is a big X. Let's not make it so complicated. Let's just call it 2 and 10. When it's a decreasing function, can you see that the corresponding, let's call this f of x. So f of 2 versus f of 10. Can you see the corresponding f of 2 and f of 10?
Yeah.
Let me just decrease the font size a bit. Over here, can you tell me f of 2 versus f of 10? Before you had 2 less than 10, agree, right? Obviously. But now f of 2 versus f of 10. Look at your diagram.
The f of 10 is less than 2. The f of
So
2.
it's more than like this, right?
Yeah.
Oh, so you need to flip the direction, right? When you put f on both sides. That's when it's a decreasing function. This works in general. Here, when we multiply by negative 1, what we are doing is we are letting f of x equals to negative x. So what we are doing is we are considering this graph. This is y equals to negative x. Then we have two numbers somewhere here. Let's say that's your what is it? 35. Okay, no. You move my graph over. Okay, here is y-axis, there is x-axis. This is y equals negative x. What happens is that we pass in, here is negative 35 over 36 power n. Here is negative 0.1. Then we look at the corresponding y coordinate. What would it be? It will just be times negative 1, so become positive 0.1, 35 over 36 power n. So at first we know, look at this, the left and the right. So you know that left is smaller than right. So in other words, negative 35 over 36 power n is less than negative 0.1. That's the original. Oh, sorry, we want more than. Okay, swap it around. Hold on. Swap. 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 Ping. In the process. Okay, done. Can you see? Negative 0.1 feed into the y equal negative x, you get corresponding positive 0.1. Negative 35 over 36 to the power of n, feed it into y equal negative x function, you get a corresponding y value that's positive version instead. Can?
Yeah.
Then we want the original inequality, this guy. What happens after we multiply by -1? Look at these two values. You got a positive 0.1 on top and a positive 35/36 power n on the bottom. So your conclusion can only be the top guy is larger. The top guy is larger. In other words, 0.1 is larger. So your inequality have no choice. You need to flip it. Can you see that?
Yeah.
That's why when we multiply -1, we ask you to flip. Can understand now?
Okay.
Because -1 is really just a negative x, which is a decreasing function. Then how about 1 over x? Like let's say you have x less than x squared. Then I ask you 1 over x. Okay, let's assume this is more than 0. Then 1 over x squared. What happens to your inequality sign?
Also.
Flip it. Yes, as well. You must change direction. Why? Because 1 over x, when the x is more than 0, it means that the graph looks like this, right?
Yeah.
You only focus on which part? Left or right? X more than 0.
The right.
The right side. Ignore the left side. Left side. What do you notice about this function? It is a
Decreasing function.
decreasing function. That's why you need to flip it around. Oh, like for example, maybe a simpler example would be like if this is 2, this is 3, then 1 over 2 versus 1 over 3. Yeah, no space. 1 over 2 versus 1 over 3. Okay? Yeah. 2 is less than 3. 1 over 2 versus 1 over 3. Not less than, it's more than. Okay.
Is it because it's to the power of -1?
No, it's because it is a
Decreasing function.
yes. When you pass, treat this as your x values. Then these are your y values. x1, x1, y1. This one is x2, y2. Then the x1 becomes a y1. What happened? You take 1 over x. Can you see this is like your x, and this is f of x. F of 1 over x2. This guy is f of 1 over x1. And because the sorry. No. This is f of x2. This is f of x1, where you have a function f of x being 1 over x. Right? X1 becomes y1 by passing the x1 inside this function. So you get a 1 over x1. And it is a decreasing function. That's why you have to flip it around. Power -1 is the same as 1 over, correct? But that just means, in general, it is a decreasing function. Can you remember?
Yeah.
Decreasing function, that's why you flip the direction. Or if you want, just memorize these two. Times -1 or reciprocate, flip inequality symbol. Okay? Or in general, pass through a decreasing function. This is the general form. Can Okay, good. Now continue solving the inequality. Okay, sorry, too long-winded. Okay, moving on. Now, how to solve this manually? Whenever you have an unknown as the power, you have to take the ln on both sides. So when you take the logarithm, is it an increasing or decreasing function? Must memorize the graph by now.
Increasing.
Increasing. So do you need to flip the direction?
No.
Don't need to flip. Just keep it the same. Now, when you ln, the power can bring down. So you're left with n multiplied by ln 35/36 less than ln 0.1. Then now you want to solve for n. What do? N is being multiplied by this guy. So what do you want to do? Multiply, bring over becomes?
Divide.
Okay, very good. So you end up with ln 0.1 over ln 35/36. So you happily put down the less than, just copy and paste. Correct?
Yeah.
Wrong. What's wrong? What's wrong?
Um,
You divide by ln 35 over 36. Can you tell me what's ln 35 over 36?
It's negative.
It's negative. So what do you just do? You divide it by a negative.
Oh,
What do you need to do to your symbol now? Inequality.
split.
Flip. Understand now? Must
Yeah.
remember to flip. A lot of students don't flip it, then you get the final answer wrong. So what do you get? So what is the final answer? Type it in the calculator for me. ln 0.1, then you divide by ln of 35 over 36. So you get 81.736. So the least value of n will now be just 82. Round up. Can?
Yeah.
Okay, great. Now, that was the question. Which question are we at now? Question 4. Question 4. Have you done question 4? Okay, you got it right. Then this part. I cannot read y'all. It's a bit blur. Wrong something?
Wrong method.
Wrong method? Question mark here. Let me read the question first. Fair cubical die has 3 faces marked with a 1. 3 faces marked with 1, 2 faces marked with a 2, and 1 face marked with a 3. All right. So it's 1, 1, 2, 2, 3. No, sorry, extra 1. Calculate the expectation and variance of the score obtained when this die is shown. So just draw the table of all the possibilities, 1, 2, or 3. Then their corresponding probabilities. 1 is just 3 possibilities out of 6. 2 is just 2 possibilities out of 6. 3 is just 1 out of 6. Then expectation, just have to pair them, multiply, add them together. Variance, you have to square it first before you pair and multiply, then add them together. Okay, then part 2. Deduce the expectation and variance of the score obtained in one row of a second cubical die, which has 1 face marked 1, 2 faces marked 2, and 3 faces marked 3. Okay, so it's a bit different this die. Okay, they were trying to be they were just trying to use some fancy trick here. By realizing that they swap it around. There's a, what is it? 1 face mark 1, 3 face mark 3. Previously it was 3 face mark 1, then 1 face mark 3. They swap things around. But honestly, there's no need. I guess you could just do it manually, draw the table again, and then calculate expectation and variance. Did you get these two answers? 7 over 3 and 5 over 9?
I don't think so.
Why they? Yeah, you did. You got the right answer. Yes. Different method. Yes, your method is perfectly fine. This is the manual method. It's perfectly fine.
Okay.
Can. This one, they're just trying to be fancy here. Maybe a bit faster. I'm not sure. 4 minus W lah, Right? Why the value will be 4 minus W. Yeah. You can think about it. 4 minus W. Yeah, okay. Can. Your method is fine. Just use your method. I think that's a simpler, straightforward way. Part 3, 2 of the first type of die and 1 of the second type are thrown together, and X denotes the total score obtained. Denoting the expectation and variance of X by mu and sigma square respectively, sigma show that sigma square equals 5 over 3 and the probability of the modulus X minus mu more than 2 sigma equals to 1 over 18. You might need to do, you need to know inequalities, how to solve inequalities here. So take note that X minus A less than, let's say, I don't know, 7. It just means that you have negative 7 less than X minus A less than 7. Must memorize this. Modulus less than something, you take that number, negative version on the left, positive version on the right, copy down the expression in the middle. the reasoning for this is you're really just asking, what is the, when you draw absolute value, you're really asking, what is the distance between x from a? And you want that distance to be less than 7. That just means you have a over here. You want the distance of, you have a x here as well. Then you have a x minus a. This guy here is 0, maybe. Then you want this distance between x minus a to be less than 7. So let me think a little bit. Hold on. Yeah, so that just means that you want the distance here and there to both be within 7. Does this make sense? Bit confusing, huh?
Yeah.
Okay, never mind. I remove the minus a. Okay, I try and explain this again to give some intuition. When you have modulus x less than 7, you're asking, let's just draw a graph. I think this is the easiest way. Y equals to modulus x. Then you have a y equals to 7. Then what do you want for the, then you want the corresponding values of x such that the modulus graph is less than 7. In other words, you are interested in the bottom part here, the part of the modulus graph that is below y equal to 7. And you realize the corresponding shadow, well, like length of projection. No, don't need dot product here. You're just finding out the -7 to positive. You just want to find the corresponding x. So -7 to +7. Yeah, I think the graph approach is easier. Can?
Okay.
All right. Then the next one is modulus x. If it's more than 5, what would it be? Hint. There's an or in between. Expand it. What do you get?
Like the plus minus.
Don't just not, that's not precise enough. Tell me exactly what to write. X.
Is more than 5 or less than -5.
Don't just or less than -5. Please write down the x as well. Or x less than -5. I strongly recommend write the negative on the left side. Negative on the left, positive on the right. Less confusing. Maybe that's just my convention. You don't have to follow. You want this part here. Sorry, maybe zigzag this part here and zigzag that part there. Okay. Why? Because you want this part of the graph that's above. Is that okay?
Okay, can.
Very good. Now we can move on. So now when you have x minus mu more than 2 sigma, here I use simple example involving x only. You have to actually expand it. So what will you get? More than left case or right case? More than symbol, right case. So you split it up as the same variable on the left, inside the modulus less than -2 sigma, or x minus mu more than +2 sigma. Okay, probability of this. When you have an or in between, it means you have to do addition. I assume that they are totally separate cases. Or it's actually the same as union. So A union B, which is PA plus PB minus P of A intersect B. But here we can treat them as disjoint sets, disjoint. Because how can you be less than how can you be less than a negative number and more than a positive number at the same time? Cannot be, right? So that means A intersect B is empty set. So you don't, there's 0 probability. So you can actually split this up into P of x minus mu less than -2 sigma plus P of x minus mu more than 2 sigma. Is that okay?
Yeah.
Okay, good. Then after that, you can proceed to simplify. Yeah, Oh, where did this bracket come from? Eh? Let me read again. Bracket here. Okay, can. So yeah, let's just read the solution lah, huh? How did they solve this? Okay. Over here, they tell you there's the first type of die and second type of die. Then they let a random variable x denote the total score of pain, right? So x will be what? W1, which is score from the first die, plus W2. That's a score from the second die. Hold on. Oh, sorry, I didn't read carefully. Yeah. 2 of the first type of die and 1 of the second type. Now, 2 of the first type means you need a W1 and a W2. We don't know what is their scores each, so we have to make them different index. Index number 1, index number 2. Then after that, 1 of the second type, that's why you have a Y over here. Can?
Okay.
Okay, good. So that's your random variable. Then you want to find the expectation and variance of x by mu and sigma square, respectively. So let's see. Expectation of x will just be expectation of this sum. Now they are independent events, so you can, or actually no, you just need to know their expectation is linear, so you can split it up into expectation y w1 plus expectation w2 plus expectation of y. But expectation of w1 plus expectation of w2, they are the same value. Oh, w1 not equal w2, but expectation w1 is the same as expectation of w2. Whoops, that should have been a 2. Is that okay?
Yeah.
Yeah, that's why here, when you split up into 2 expectations, it becomes 2 times. Then for the y, just becomes expectation of y. Now, how do you find expectation of w, expectation of y? We already calculated it before, right? Here and here. Then you just have to substitute in. 2 times 5 over 3 gives you 10 over 3. 2 times 7, just one copy of 7 over 3, just copy and paste it. And you get 17 over 3. Now, sigma square is what? Here they tell you sigma square represents the variance. Oh. So that means you can just calculate the variance of x to find out what it's to show that sigma square is 5 over 3. Okay? And actually we also found mu already. Oh, we found mu already. Because mu is what? What is mu? It represents the you're confused?
Expectation
Of what? What random variable?
of x.
Yes, of x, where x is the
Total score of 10.
Okay, very good. It's okay, clear so far. Hopefully you're not confused. Wow, you cannot reply straight away. A bit funny, Okay, hope you understand what's going on. So sigma square is the variance of x. Then you just need to substitute the x with the die 1 plus die 2 plus the second type of die, 1 copy of the second type of die's sum, which is the random variable x. Just sub in only. Then variance, when you do addition, you can actually just split it up into each copy. Variance W1 plus variance W2 plus variance of y. Then you realize that even though W1 not equal W2 not equal y, we can actually calculate the variance for each guy. I mean, and we realize that their variants are still the same. Oh, variance of W1. Okay. Likewise over here, variance of W1 equals to variance of W2. Which means that this guy and this guy is the same. They should both be the variance of W, which we already found out as 5 over 9. So 5 over 9, 5 over 9. But what's variance of Y? Coincidentally, it is also 5 over 9. Okay, you also calculated that value. You are correct in your table. And over here, This is fine. Okay, they are the same. Coincidentally, not really. They're just off by a constant. That's off by a constant variable. I mean, off by a constant term. Yeah, so 5/9 as well. Then you can finally get your 5/3. This 3 times, they're just being fancy. Don't need. Just immediately substitute in and add them together. If you can see it's 3 times, that's good. You can type faster on the calculator. But at the end of the day, this is all that matters, 5/3. Okay, good. Can. Now, the mu and sigma, we already found out, right? This is mu, and that is sigma square. So we can just sub in. If you remember the question, it was asking probability of modulus x minus mu modulus more than 2 sigma. Then you just substitute the mu with 17/3, substitute the sigma with square root 5/3. Okay, sigma square equals 5/3. The square is really a power 2. So you have to take the square root to get 5/3. And take note that sigma by definition is always positive, so you don't need to plus minus. Is that clear? Always plus. Is that clear?
For sigma.
Yes, correct. Sigma stands for standard deviation. It's by definition always positive.
Okay. Okay.
Yeah, don't need negative. Yeah, that's why over here 2 sigma becomes 2 times square root 5/3. Then here, please take note, this is not a random, this is not a normal distribution. You don't get normal CDF or anything. You need to do the inequality trick. So split it up as less than the negative or less or more than the positive. Okay, here they wrote down more than the positive version, then less than the negative version. Do you see why this is the case? They skip a few steps. Okay, I show you the, okay. This will be modulus less than 2 times whatever. Means if you open up the modulus, you have the same random variable inside x minus 17/3 less than the negative version of the constant on the right hand side, 2 times square root 5/3. No space. Let me just zoom in a bit. I mean zoom in and write it a bit smaller. Okay, this one. Okay, wait. I copy down first. If not, it's confusing. Okay, like this. When you have a modulus more than 2, it's just that same expression inside the modulus, but less than the negative, or that same expression inside the modulus, but more than the positive of the right hand side. Is this part clear to you?
Yeah.
But when you have a or, these two cases are totally separate. So you can actually split up into a sum. Alternatively, you can also bring the 17/3 to the right hand side first, while keeping inside the P bracket. Like haven't split up yet, the or will split up into a sum of individual probabilities, P of this guy, and then you plus. That's the next step. But what I did here was I brought the negative 17/3 over to the other side of the inequality. Is that clear?
Yeah. So the or do I memorize?
Memorize. Yes. When you have more than, it just becomes an or. Modulus of more than a constant just becomes an or. This guy less than negative of the right hand side. This guy more than positive of the right hand side. Okay, it's because of the example I gave you. Maybe I give you another example. This will be y equal x minus a modulus. Oh, right. Y equal x is this one. Minus a means you shift towards the right. Oh, okay. Wait, my graph is wrong. Should be this one. Like this. There is a A. Then after that, you have a y equals to some k. Then if you want to solve like modulus of x minus a more than k, what would this be equal to? This will just be the same as x minus a less than negative k, or x minus a more than positive k. Bring over, you get x less than a minus k or x more than a plus k. Do you get that?
Yeah.
This point here is actually just a minus k. This point here is actually just a plus k. Coincidentally, the distance here is a k. Distance here is a k. You can prove it on your own. Do some coordinate geometry, but not important. Then we want, when we say modulus more than k, we are interested in the two branches. Here and there, the part that's above the y equals to k. And then we are interested in its corresponding shadow. So it's this region here and that region there. X less than a minus k, x more than a plus k. A plus k here to the right, so x more than. Then a minus k and all the way to the left means x less than a minus k. Move to the left, which is what I've written over here. Okay, that's how you solve it. But of course, it's not just a and k, it's 17/3 and 2 times square root of 5/3. Okay, this part clear so far? Good.
Yeah.
Then after that, you can split the OR up into a sum, which is what we have over here exactly. They swap the order around. Right, go to left, left, go to right. But it's just addition, right? 2 plus 3, 3 plus 2, you can swap around. So that's why this is still equal. Then after that, you can calculate the probability already because x, because x is a discrete random variable. Okay. Take note, what do I mean by discrete? Discrete means whole number. Means it can only take on whole numbers. So if you look at this value in the calculator, you get 8.25 approximately and 3.08 approximately. When you have x strictly more than 8.25, what's the what does that mean? It means that your x can only be equal to 9.
Yeah.
All right. Actually, why should it be only equals to 9? Let me think. That's a bit funny. Actually, technically, why stop at 9? Why do you want 10 or 11 or 12? Why you don't want more than 8.25, right? Can be and you want whole number. So after 8.25, okay, no choice, has to be 9 now. How about but more than 8.25? You can also be 10. Why you don't want x equal to 10? So maybe you should have, instead of x equal to 9, this one, what if it should instead be p of x equal to 9 plus p of x equal to 10 plus p of x equal to more than 8.25? Just keep going. Just keep going. It's still more than 8.25. Why do we not keep going? Actually, you can, but all these values will actually be equals to 0. Do you know why?
No.
Read the question. What's the situation here? Random variable x. X denotes the total score obtained. Obtained from what?
The two dice, like
Of the first type and 1 of the second type. What are the values on the first type? First type. 1, 2, or 3. Second type, also 1, 2, or 3. So what's the maximum score you can get? First, two of the first type, 1, 2, 3. So how about the first die is a 3, second die is a 3, third die is a 3. Then that will give you the maximum already, right?
Yeah, 9.
9, maximum. So what happens if you consider 10, 11, 12? Impossible.
Yeah.
That's why it's equal to 0. Understand?
Yeah.
Very tricky question. And how about this part here? X less than 3.08. Okay, but you already said that it's a discrete case. So it can only be whole numbers. So less than 3.08, so it must be 3. But less than 3.08, how about x equal to 2? Or x equal to 1? X equal to 0? X equal to -1? Why do you want to consider those?
Because there must be 3 throws, so the minimum is 1 each.
One each, which gives you a total minimum total of 3. That's why it's only 3. Very good. You understand now. So these are the only 2 possibilities.
Yeah.
Understand? Okay. Yeah.
Yeah.
Maybe you can write some note on your own. Minimum and maximum. Maximum is 333. Minimum is 111. Oh, that's why you only have these 2 possibilities. Okay, so then you just calculate the probability for each case. Do I need to go through this part?
No.
No need, okay, just go and count the possibilities and then calculate probability. It's, I think, quite simple. Okay, and it's independent. That's why you can have 1/6 times 1/6 times half, or 1/2 times 1/2 times 1/6. Get the final answer 1/18. Can?
Can.
Okay, good. Now for binomial. Oh, how much time do I have?
No. I don't know.
Okay, let's just go through. Which are the questions that you got wrong? Okay. You printed it out or something. Or you're using iPad.
Yeah.
Yeah. Okay. Can. Good. Can I just read this? Question 1. Suitability of using a binomial. Just need to know the 4. Okay, actually just 3 lah. 3 key properties. Must memorize one. Number 1, must have a success or failure as outcomes. And they are, what do you call it? Disjoint. Or you can also call it mutually exclusive. Like you cannot have 70% chance success, 30% failure. No such thing. You flip a coin, you either get heads or tails. No other in-betweens. That's what it means. Second one, must have a fixed n number of trials. Oh, let me make it a bit more precise. Independent trials. So actually, number 2 is actually 2 conditions stated in the same sentence. Must have a fixed n number of trials. So like you flip how many coins? Flip 3 coins. Okay, 3 means 3. You don't go and flip 2.5 coins. Don't flip 3.1 coins. Don't flip 4 coins, 5 coins. You say 3 must be 3, must be 3 coins. Must commit to that fixed number. Is that okay?
Yeah.
No infinite number of coins as well. Like, and then there's some geometric probability, or if every time you flip the coin, the probability gets smaller and smaller. No such thing. Number 1 problem is you don't want the case where you have infinite number of coin flips. That will not be binomial. Also, you don't want the probability of each coin flip to be different, which brings me to point number 3. There must be a fixed probability of success equals to P, which means that the probability of failure will be 1 minus P, usually denoted with a Q. 1 minus P is the same as Q. Yeah, these are the 3 conditions. Need to memorize. Also, you must check whether you satisfy these 3 conditions, and then you will be done. Here I say fixed means you cannot vary the probability. Like coin heads get half probability, tail you get half. You flip the second coin, it must still stay the same. So this also means that you don't allow the cases where you remove without replacement, like draw without replacement, because the probability will keep changing. You don't allow it. It is not a binomial. Okay, so let's read the question. So state with a reason whether binomial could be used in each of the following problems. If binomial distribution is an acceptable model, define the random variable clearly. So x tilde b, give me the n, give me the p. The n, the p. Okay, so gambler has a biased coin for which the probability of getting a hit in any toss is 0.56. So that means it's a fixed 0.56 probability of success. And find the probability of getting 6 hits. So n equal to 6. if he tosses the coin 8 times. Oh, wait, sorry. Getting 6 hits if he tosses the coin 8 times. So n is equals to 8 here. Out of and you want 6 particular of those 6 particular out of those 8 outcomes to be hits. Okay, so it's a yes. Yeah, 2 mutually exclusive outcomes remains constant at 0.86. And you should also mention that they are independent events. Each coin flip is independent. Yeah, just mention independent somewhere. Each coin flip is independent. I mean, probability of getting a hits on one coin is independent of probability of getting a hits on another coin. Just somehow phrase it nicely. Then let X denote the number of hits obtained by the gambler in 8 tosses of the buyer's coin. Yeah, good. So you must always mention when you are defining your random variable, this part here, in 8 tosses. This will specify the n. Then number of hits here, that's what the X value will take on. How many hits? In this case, you want 6 hits. That's why you have P of X equal to 6. Here, wrong already. You do not write down 6 over here. That should be your P value 0.56. It's always X tilde, TILD tilde, capital B, bracket, N, comma, P, the probability of the successful outcome. Probability of the successful outcome. Don't write down 6. Wrong. 6 is the value that the random variable X will take on. Okay?
Yeah.
Then part B, let's see. Fair coin is spun until a hit occurs. Spun until a hit occurs means you have to flip it. You could possibly flip for an infinite number of times. Tails, and you just never get a hit. So is that a fixed n number of trials?
No.
No, it could be an infinite number. So that's why this is wrong.
Okay.
No fixed number. Yes, correct. Then part C, a jar contains 49 balls numbered 1 to 49. 6 of the balls are drawn at random without replacement. Probability P no longer stays constant. Nope, not a binomial. No fixed number of balls drawn to have an even score. Yeah. More significant point is not the number, but rather the probability of success. It's not fixed. Yeah, but you got the idea. Just need to improve it a bit more. Must mention the probability is not fixed, not the number. We focus on the probability. Okay, next. Question 2. For each situation, determine whether RV can be modeled by a binomial distribution in the event that it cannot state a reason why. Number of hits obtained when a buyer's coin is tossed 3 times. A is yes, B, number of accidents occurring in a factory. Okay, maybe I should also mention A1, buyer's coin, actually they never specify the P value. So actually, technically, it might not be possible because they never specify the probability value. You get what I'm saying? Yeah, okay. The answer is a yes, but then of course it's not. I feel that it's not precise enough because they never said buyer's coin. So what's the probability now? Is it still 0.5? Is it 0.6, 0.4? They never specify. But okay, maybe I am being too strict. This is actually still possible. Okay, then okay, actually, do you mark this already?
Yeah.
Yes, then I'm just gonna I assume that only those that are red you want me to focus on, right?
Yeah.
Okay. Let me read this. E part 2. I'll just jump straight to the relevant one. Part E is asking telling us about the situation. The number of red balls obtained when 3 balls are chosen from a pack contain 1,000 red and 2,000 blue balls. With replacement or without replacement. So here, part 2, know the probability of obtaining each color ball changes after every trial. Let me think. Okay. Right. Because the denominator is big. This one is getting a bit too specific already. Here they are trying to mention the idea of approximating a situation as a binomial distribution because the n is large. I think you can ignore E part 2.
Oh,
Sorry.
so that is wrong.
No, the answer is okay, it's not exactly, it's not wrong, it's actually correct. It's just because they already mentioned that it can be used as a good approximation. It's just not exactly the same. It is definitely not exactly the same. But you must consider, because here, like let's say you are trying to calculate the probability of obtaining number of red balls obtained when 3 balls are chosen. So let's say you want to obtain 2 red balls, okay? From this pool of how many? 1000 red plus 2000 blue. Let's say you want to find the probability of obtaining exactly 2 red balls. What would that be? It will be equals to 1000 out of 3000 multiplied by what is it? 999 over 2999. 999 over 2999 is approximately 1000 over 3000. So that means that this is approximately equal to 1000 over 3000 squared. Right?
Yeah.
Approximately. Then this is really just almost the same as if you're saying you let X be a random variable for the number of red balls drawn out of 3000 balls. Then it follows a binomial distribution where you are drawing how many balls are? You're drawing 2 balls. The probability of getting a red ball is 1000 over 3000. A fixed probability. Pretend that it's fixed. Even though it's actually not fixed, it will decrease. Then what you're doing is you're finding P of X equals to 2, which means you get 2 choose 2 times probability of success raised to the power of now 2 balls, then failure 3, which will be 2000 over 3000. Or 1 minus 1000 is 2. 1 whole minus away 1000 over 3000 is 2000. Then power 0. Right? This is like using binomial, which becomes 1 times 1000 over 3000 bracket square times 1, which is the answer there. This probability using binomial distribution versus this answer where you use the countdown method, the drawing without replacement, they are approximately the same. That's what they're saying.
Oh.
Okay. But I think you can ignore this. It's a bit high level already. You don't need to know this. Okay, you can approximate it, but you here they say it can be modeled, a very vague question. I doubt you will be asked this during A levels. Okay, moving on. Part F, number of seeds in a chosen packet of 12 seeds that fail to germinate. Wait. No, yeah, there is let me see. Fixed number of throws. Wait, no. You already answered it correctly. They are not independent of each other. Yes, correct. Okay, then I'll just move on. Next. Okay, the ones that you take, I'm just gonna ignore, okay?
Yeah.
I'll just focus on the ones you got wrong. Okay, part 4. Okay, let's go through that. Part 4, what is this? Part 4. I hope you won't fall asleep because it's already quite late. Haha. So X follows binomial distribution, N is 10, P is 0.2. You want to find out part 4, which is P of 4 less than equal X less than equal 11. Okay, key thing to take note is this is really just telling you P of X equals to 4 plus P of X equals to 5 plus 6 plus 7 plus 8 plus 9 plus 10. I just put plus dot. I hope you get what I'm saying.
Yeah.
I skip the numbers in between. Then P of X equals to 11. Yeah, no space. Okay. Wow, very long-winded. If only there was a faster way to write this. Do you agree with me that maybe if I rewrite it like this? 4, 5, 6, 7, 8, 9, 10, 11 is really just the same as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, just copy and paste. But you have to take away that 1, 2, 3.
Yeah.
You minus away 1, 2, 3. Okay, I know this is not precise math notation, but you get the idea.
Yeah.
Think of it as a set, I guess. Don't make it so complicated. Okay, so you get the idea already. So same thing over here. This guy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That could be all the possible values that the random variable x can take on. So this is actually the same as p of x less than equals to 11. This represents p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 dot 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 all the way to plus p of x equals to 10 plus p of x equals to 11. Are they equal? Are they equal? Of course not. How much? Why? What? But they're almost the same. They're almost the same. They're just off by an extra portion here in the front. There was an extra p of x equals to 0. Oh, sorry, I forgot a 0. Sorry. Random variables can always start from 0. Yeah. Okay, must have a 0. So it's 0, 1, 2, 3, 4, 1, 2, 3, 4, all the way to 11. That's what this represents. P of x equal to 0 plus P of x equal to 1 plus dot 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 plus P of x equal to 10 plus P of x equal to 11. So now they are not equal. What do you need to take away? Minus away. We counted an extra 0, x equal to 0, 1, 2, and 3. So you need to get rid of those. So P of x equal to 0, P of x equals to 1. Wow, my hand getting tired already. If only there was a faster way. If only there was a faster way. All this is really just minus away P of x equal to 0 plus P of x equal to 1. If only there was a faster way. I just factor out for you while I wait for you to give me the answer. If only there was a faster way. If only there was a faster way. If only there was a faster way. What's a faster way to write this? X less than equal to 11 is start from 11, count down all the way until 0. Here we got 0. Here we got 3. Altogether, this is P of. Tell me. X
is less than or equal to 3.
Very good. Yes. So in short, this is just equals to P of x less than equal 11 minus P of x less than or equals to 3. Are you able to go from here to here straight away in less than 3 seconds?
No.
Yes. Practice until you can. You better make sure you say yes. This is one of the 3 marks everybody in A levels know.
Oh, okay.
Must know. So you must understand. You go from 0 all the way to 11. You take away 0 to 3 just before 4. Then that's how you can get the guys from 4 to 11. Is that clear?
Yeah.
Okay. This intermediate working, you see it one time. Please don't write during exam. Waste time. Maybe it might be useful if the number is small, but here 11 is quite big. In fact, 4 is already quite big already. You need to write 5 times. So try to learn the shortcut. Must know the shortcut. If not, you won't have time to finish the paper.
Okay.
3-hour paper also not enough. It's very long-winded. Okay, so now you have to use GC. Do you know how to type on the GC, this one? Maybe I just show you for the video, I guess. Then you can have a record. Okay, you can see the screen. Okay, let me check if I'm in the correct mode. Function mode. Okay, good. Now I'm just going to go to second, distribute. Go up until you eventually find binom CDF. Okay, take note here we want CDF because we have less than or equals. Less than or equals to, what is it, 11, right? Here the x tilde b is 10, 0.2. So that means that number of trials here, that's your n value 10. So let me clear everything first in case you're confused. Okay, let me just clear this. Just put 0. Okay, so let's say we pretend that we are starting at the top here. Number of trials is 10 because of 10, 0.2. Then the p value, it will be the 0.2. So we just key in 0.2, 0.2. The next x value, so you notice the first guy, we want p of x less than or equals to 11. Make sure you have the equal there. Then since we have the equal there, we just key in the 11. Press enter. this will give us the first part, p of x less than equal to 11. So this is really just p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 plus dot 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 until plus p of x equals to 11. Then after that, you subtract away what? Second, distribute again. Go to binom CDF. What do you key in? 12 is still 10. P is still 0.2. But how about x value now? Not 4, man. You see 4 less than equal x less than equal 11. You see 4, then type 4 lah. Correct or not?
Cannot.
Cannot. Why?
Take away the
Because you must take
4.
away the front part, the number just before 4. So it has to be a 3. Don't blah blah. Don't just see 11, 4, then you just key in 11 and 4. Wrong. Must have the equal sign. Okay, then that's your final answer, 0.12 lor. Is 0.1208. Round up, then you to 3SF and get 0.121. Can? Let me change back to my. Okay, hold on. Let me set up a screen so I can show both my calculator and the screen at the same time. Oh, hold on a second. Calculator here. And share screen here. Okay. I hope you can see the calculator.
Yeah, can.
Yeah, here the zigzag. Okay, I don't make it so messy. You can read it better if I don't zigzag. But I still want to cross a few times. Don't do this during exam. Do this instead. Okay, then after that you get the answer of 0.1208. I'll just copy down first. 7. And then round off to 3SF 121. Oh, same answer. Okay, very good. Now we move on to part V. Now this time, the answer changed. So in question 1 part V, we have A part V. We have Px, P of 4 less than x less than 11. Oh no, what happened this time? No more equal sign. So is it just 11 then 4? Just key in 11, key in 4, then minus?
No.
No, so how? You need to understand what does this mean. When x is a binomial, it's what we call a discrete distribution, meaning x can only take on whole numbers. So if 4 is less than x, what's the smallest whole number x can take on? It must be
3.
No. Must understand the number line. Here is 4, here is 11. 4 strictly less than. Do you put empty circle or solid circle?
Empty.
Empty circle, because it's strict, so you don't include all the way until 11. Also strictly less than 11, so empty circle. Then I'm asking you, within this interval, you only accept whole numbers. So I hope you can see that these intervals are to the right of 4 and to the left of 11. So what's the next closest whole number? Not 4.
5.
Is it 3? Yeah, it has to be 5. X more than 4. So is 3 more than 4? How can 3 be possibly more than 4? Cannot, right?
Yeah.
So that's why your answer there is wrong. I'm expecting you to give me a 5 less than or equal to x. Okay? How about 11? Same thing here. I don't want less than, I want less than or equal. What will it be? Less than or equal to?
10.
10. Okay, very good. That's your first step. Actually, that's your step 0.1. Now we step 0.2. We have to split it up as, what is it now?
5 less
X
than
less than or equal to, no, it will always be something minus something. P of x less than equal to something minus P of x less than equal to something. Follow this pattern.
Equal to 10 minus
P of x less than or equal to P of x less than or equals to. Take the pattern. 5 less than equal x less than equal to 10 means what? 5, 6, 7, 8, 9, 10. X less than equal to 10 means what? 0, 1, 2, 3, 4. Then 5, 6, 7, 8, 9, 10. What do you need to take away now in order to get from 5 to 10 only?
0 to 4.
Take away 0 to 4. So x less than or equal to
4.
Ah, you don't know this, ah? Okay. Wow, you need practice. This is the basics, very, very basic. Must remember this. Okay, let's try on. Then, of course, you key in the calculator. Let me show you again. Here, when you have less than or equals, you use the CDF function. So let's take a look at the calculator again. So what's the keystroke? Second, vars on top is DISTR, distribution. Or second, the blue color, distribution. Click. Scroll. I think newer calculators is white color, but you just go and figure out the DISTR page. Over here, binom CDF, enter. What's the trials now? Still the same lah. The question is easy. It's kind on you. The N is the same. The P is still 0.2. How about X value? What is X value?
10.
Yes, correct. The first one is 10. Key in the 10 and then you equal. Is that the answer? No, you have to minus. Second, distribution. Go back to binom CDF. Still got N equal to 10, P equals 0.2. X number of trials now is what?
4.
4. Very good. Not 5. And you get 0.032. Approximately 0.0328 3SF. Can?
Okay.
Okay. Good. So any other questions? I mean, I don't know. You know the formula NP and NPQ. NP at 1 minus P. Okay, good. Part 2. What's this? B part 2. Let's see. So B part 2, y is the random variable such that y equals to 3x minus 2. So that means I would also, okay, that means something. I'll have to make use of my expectation and variance formulas. Part B part 2, is it? You want to calculate Py more than 20. Okay. Can. So in this case, Py more than 20 is actually just 1 minus P of y less than or equals to what?
19.
Yes. Let's think carefully. This one you start from more than 20. Y is 3 times of a discrete minus away a discrete number. Discrete means no decimals. So y will also be discrete. So if y is more than 20, what's the smallest y?
21.
21, 22, 23, 24, then the smallest is 21, right? Then so this is asking for probability of 21, 22, 23, 24. Y equals 21 plus P of y equals 22 plus P of y equals 23 plus so on and so forth. But smallest is 21, right? So what do you need to get rid of at the front? Is it 19 or is it 20? Just before 21 is. Just before 21 is
20.
So that's why over here it should be a 20. Okay.
Okay.
You're getting rid of the y equals 0 all the way to y equals 20 so that you can get the others, not 0 to 20. So it should be 21, 22, 23 onwards, which is exactly what they mentioned over here. More than 20 is 21, 22, 23 onwards. Then P of 1 minus P of y less than equal to 20. Then how do we calculate that? How do we calculate that? So over here, we need to substitute the y. I think so. Yeah. Substitute the y. Then in that case, we already know what's y, huh? Y is what? 3x minus 2. Right?
Yeah.
Then we can play around with the inequality within the probability. Just treat it like a normal inequality. -2 bring over becomes +2. So 3x less than or equal to 20 plus 2, which is of course just 22. I'll simplify straight away. But then you have a 3 times x, so what do? Bring over becomes
22/3.
very good. So 22/3. I'll just get rid of the 3 there. Do you need to flip the direction of the inequality? Divide by +3?
No.
Don't need. Very good. Then this is x less than or equal to 22/3, which is let's just check the calculator. 22 divided by 3 is what? 7.333. Okay, 7.333. So if you want, so remember again, x is a what kind of random variable? Discrete or continuous?
Discrete.
Discrete means it can only take on what kind of numbers?
The integer values.
Very good. So if you want less than or equal to 7.33, what's the largest value of x? Equivalent to 7. So this is exactly equal to is equivalent to if you replace the 7.33 with 7, because of the fact that x is discrete. Don't need to explain on. Just put equal and give me the correct value. Okay. Yeah, this one. Then now you just need to key in the calculator. So let me show you. 1 minus away probability of the binomial random variable x less than or equal to 7. So second distribute again. When you see less than equal, you just use. When you see less than or equal, you just use CDF. Can not P, use C. Can CDF is basically helping you to add all the probabilities, individual probabilities, Px equal to 0 plus Px equal to 1 plus Px equal to 2 plus ... until Px equals to whatever value you specify. In this case, I'm going to specify 7. Is that clear?
Yeah.
Okay, x less than or equal to 7. Yeah, so just key in 1 minus and you get your answer. Oh, what's that? That's such a small number. Okay. You can math and then decimals. Does it help? Okay, it doesn't help. So they gave you in the exponential form already. So in that case, you just use your GC law. I mean, just use your knowledge of exponential scientific form. This is just times 10 power negative 5, right?
Yeah.
You can leave that as an answer actually, then round off to 3SF, so 7.79. Or you could just follow the answer key, divide by, so times 10 power negative 5 means divide by 10 5 times. So move the decimal 5 times. You introduce 1, 2, 3, 4, 7, 7, 9, 2, 6, 4. Okay? It's not exact, of course. The calculator has limits, cannot display everything. Is this correct? Move it 5 times. Correct, how? Right, 10 power negative 5 means divide by 10 power 5. So divide by 10 5 times. Move decimal to the left 5 times. Right?
Yeah.
This one scientific notation, you understand or not? When they put in -5 on the calculator, do you know that this is the same as times 10 power negative 5? Okay, do you okay, this one exponents, I hope you're fine with it. Negative means divide. Is it okay? Do I need to explain more?
No, the calculator can find
the decimal. Okay, good, can. Then you just need to convert into 3SF. So here 3SF, do round up or down? Down. So 779 3SF. Okay. Is this the right answer? Let me see the answer. 779. Okay, good. Okay. Next question. Let's see, what is your next question? 5. Wow, circle the whole thing. What happened? Question 5. I don't know press what in GC to form table. Okay. Can. Part A. Given that x follows binomial distribution n, 1/1/3, find the least value of n such that p of x more than equal 5 more than 0.6. Okay, let's do that. Since you're using, okay, I'm just going to copy the question. Then I solve it. Hold on. Yeah, okay, let's take a look. So what we have, part A, x is a binomial following the having n value of n, unknown n, and p value 1 dot. So we want to find the least value of n such that px more than equal 5, more than equals to 5 is more than 0.6. Okay, so over here, for binomial distribution, you must always make sure your inequality symbol is this way, less than or equal. Can you memorize this for me? Binomial distribution, when you want to use the GC to calculate probabilities of inequalities, inequality symbol, okay, no, inequality setup should be the random variable x, random variable less than or equals, must be this direction. Due to limitations of the calculator, unfortunately, you need to memorize this. Must be this direction.
Okay.
For later on normal, you are more it's more flexible. For binomial, unfortunately, it's very not flexible. You must less than or equal. Must memorize this. Must be less than or equal to some number, some happy face number. A number. Okay, must be this format. Clear?
Yeah.
Okay, problem over here. More, less than or equal. More than or equal is not less than or equal. So what do you do? The trick here is 1 minus. 1 minus what? More than or equal 5 means 5, 6, 7, 8, 9, 10, all the way until n. Then what's the opposite?
4.
Less than or equal to
4.
4. By the way, I also should emphasize should always have an equal. So let's say I give you a quick example. If it's px less than 3, do you key in 3 in the calculator? For let's say x follows binomial of I don't know, 5 and 0.5.
No.
No, you have to convert into less than or equals to
2.
2. Then after that you use GC. You must key in value to be 2. Must always have an equal sign. Is that clear?
Yeah.
Okay, equal 4. So change to 4. More than 0.6. I'm just doing a substitution here. Now you can make px less than equal to 4 the subject. How? Just bring the 1 over 0.6 minus 1, negative 0.4. More than, right? Don't forget the negative in front. Then you times negative 1 on both sides. You get plus. Change the direction to a less than. Is that okay? Was it too fast? I need to repeat?
No.
Can? Okay,
Yeah.
good. So now you want less than positive 0.4. Then you realize a problem. But here is an unknown n. How to key in the calculator? How to key in the calculator? That's when, let me show you. You need to use your y equals already. Go to y equals. Then remove all the old data. Y1, you have to key in p of x less than or equal to 4 and y equals 0.4. Let's just key in the right hand side 0.4 first.
Okay.
Then after that, second distribution on y2, go to binom CDF, then you key in n. In this case is number of trials. Usually is fixed number, right? But here is an unknown n, so you just key in a random variable. Just key in the variable x here. Then p value is 1 over 3, so just key in 1 divided by 3. X value here is what? 4, so key in a 4. Clear so far?
Yeah.
There's no n, so you have to use the x. Yeah, just the variable. That will be a binom CDF. So they'll draw a graph for you. Let's just draw the graph now. Sorry, press graph. That's y equals 0.4. Then after that, you have the other graph. Oh, hold on. Let me think a bit. Oh, right. they might not be able to draw this. Okay, sorry, don't draw a graph. Instead, draw second. Press the second button and press table, the graph button. You're using your GC, right, together with me?
Yeah.
Yeah, okay, good. So now let's take a look. We want the value of the px less than or equal to 4, which is actually all these values here. All these values here. And all these x values can you see on the left, 10, 11, 12, 13, all the way. All those are your n values. Okay? All those are your n values. Because your variable x, remember, it was for the it took the place of the letter n. Also x in this column here, I go up, I go down. I hope you can see. Those are all your possible n values. And for each n value, there's a corresponding y. You plug in a x, you spit out a y. All these different values of y. We want these values of y, which is y2, which is p of x less than or equal to 4, to be less than 0.4. So I hope you can see. Here is 0.55, 0.47, 0.40, and then 0.339. This is the place where it changes. Can you see?
Yeah.
So what I want you to do is to copy down these two rows. I'll do it for you. So for presentation purposes, just present it this way. Sorry, my y1 is a bit redundant. Yeah. You just draw a table like this. I call it x here, and call it px less than or equal to 4 here. That's your y lah. That's your y2. Don't need to write y2, just write px less than or equal to 4. Then just key in just copy down the value of x where it's slightly above 0.4 and then directly below 0.4. So in this case, it will be 15 for x. You get the 0.40406. Then if it's 16, what's the value? Let's see. When x equals to 16, we get the p value to be 0.33912. Okay?
Yeah.
So what do you think is the answer for 16? I mean, what is the answer for n? I revealed the answer. Oh my goodness.
Oh, it's 16.
Yes, it's 16. But the least value of n is 16. Yes. Okay. Can?
Can.
That's the first value where you manage to obtain a corresponding probability that is less than 0.4. Okay, good. Now let's move on to part B. So part B, you have y. Yeah, let me copy down first. Hold on. Okay, maybe I'll just. Yeah, I'll just copy down. You have a random variable y, binomial distribution, n is 200, p is 0.6. Find the least value of r such that p of y less than 2r is more than or equals to 0.8. Okay, so what do you do now? Remember what was the requirement?
Must be less than or equal to.
Variable on the left, random variable on the left, big letter capital Y on the left. Random variable, the inequality symbol is less than or equals, and then number on the right. Just take note, 2r is just some number. Don't worry, don't be scared of the r. It's just some number, it's a constant, like maybe 5. So 2 times r is 2 times 5, which is 10. It's just some number. So what do you do when you have, like for example, p of y less than 10? What do you do when you want to use GC? You want less than or equal, right? So this is p of y less than or equal to?
9.
9. What do you do to get from 10 to 9? You
Minus.
minus 1, right? So
Yeah.
here you have 2r. What do you do now? Less than or equal to? 2r?
Minus 1.
Very good. Don't be scared of the 2r. Just write down 2r, then minus 1. Perfectly fine. Okay?
Oh.
More than or equals to 0.8. Now you have y less than or equal to 2r minus 1. You can key in the GC. Okay? How? When you have an unknown r here, usually we got all 3 numbers, got n, got p, and you have the value here. But here we don't have the value, we only got a variable r. What do we do? What do we do? We go to y equals, maybe I'll just clear everything first. Then I'll just go to one of the y's. I'll just go for y1. Second, distribute. Are you trying this on your GC? You should try. I can wait for you. Okay. Then go to binom CDF. So number of trials is what? N is 200. Probability value is what? P. Trials is N, number of trials. N for number of trials. Then P is P.
0.6.
Yeah, the other value 0.6. Oh, 200 comma 0.6, that's your N comma P. If you cannot remember, go and write this down 100 times. X tilde B N comma P, number of independent trials. The probability of success. So when you think of success, you must think, oh, binomial needs what thing? Needs two mutually exclusive outcomes, success or failure. Success or failure. Okay, good. So now we can key in the GC. What do you key in for X value now? Instead of just 9 or 10, it becomes 2x minus 1. Okay, 2r minus 1 becomes 2x minus 1. Is that clear?
Yeah.
Okay, then now we go down, paste it. And just draw a second table. What do you notice? Go right, and then you can reach this. Wow, e power negative 50, negative 48. These are very, very small numbers, right? You have to press down all the way until you get more than or equals to 0.8. I hope you notice it's increasing. Right? From negative 40 power to negative 36 and negative 35. It's getting bigger and bigger, right?
Yeah.
Sorry. So that means your R value, these X at the side, right, is representing your R already. Remember the second distribution, we already selected, ayo, wrong. We already entered 2x minus 1 over here. I hope you can see at the corner.
Yeah.
So X is already R. X is already R. So second table. Wow, so slow. I need to scroll down all the way, man. If only there was a faster way. There is.
Paper.
Second table set. Then table start. Pick a better value. I don't know. Just guess and check. 50. Second, okay, let's say I go even bigger. 200. Second table. And then I start seeing 111. Why? What happened? Too big already. So you need to work backwards. So second table set, maybe I go for halfway in between, maybe 100. Okay, then second table set. Still too big. 100. You see all ones. Oops. All ones.
64.
So, yeah. Is it 64? Okay, let's just go for 60. Guess and check, no choice. But half the selection each time, huh? Do you get what I mean by half the selection each time?
Yeah.
So like if you start at 10, 10 is too small. 200 is too big. Then you go for the middle. Pick 100. Then if it's too small, you need to make it bigger. Then you just go for 150. Too big, then you want to make it smaller. Then go for 125. Too small, then you make it bigger. Then 100, something in between 100, 12, 30, 36, something like that. Oh, then you realize you are just halving the number of methods. So it's actually quite fast. Guess and check. It's also quite fast. Okay, then what you realize? Here, 0.46, 0.58, 0.69, 0.78, and finally 0.86. So that is your answer already, 64. Okay. Yeah. So R using GC, R equals 64. Alternatively, you can also try to, not necessary, but it's good practice. You can, to convince yourself you're on the right track. You can put down an R value here and then a P of Y less than or equals to 2R minus 1. Then you just list down some examples. So 63 and 64. That would be 0.8607 for 64R when R equals 64. When R equals to 63, it's 0.785805, whatever. Yeah, so then you can see straight away, this guy is more than equals 0.8, therefore answer is R equals 64. Okay. All right, good. That is part B. Move on to part C. Let me know if you are if you have any questions. So part
Okay.
C. Okay, let me try and shrink this down. I want to squeeze this in one page. All right, let's take a look at part C. So now we have Z, it follows a binomial distribution 24, P. Now we have covered all three cases already. If you look at your question, it's actually very good. It gives you all three cases. Unknown N, this one is unknown happy face number, and unknown P value. So all three cases are covered in this question. Okay, let's just look at part C now. 24, P. Find the least value of P such that P of Z more than equals to 10. More than equals 0.9. First step, variable on the left, what should be in the middle?
The less than or equal to.
Less than or equal. So what do you need to do when you have more than equal and want to convert it to less than equal? You have to take
Less than or equal to 9.
no. Not straight away. What else do you need? Z more than equal to 10 is 10 plus 11 plus 12 plus 13. If you just straight away convert into Z less than or equal to, was it 9?
Yeah.
Is that, are they equal? No. What should you do?
Uh, 1 minus.
1 minus, yes. Some students are faster, they will just 1 minus on the right hand side, but I prefer to do it step by step. This guy more than equal to 10 is the same as 1 minus P of Z less than equal to 9. Can? Then copy right hand side. Okay, so far?
Yeah.
Good, good. Now we can continue. So if you have P of Z less than equal to 9, we need to make it the subject. So negative P of Z less than equal to 9. The plus 1 bring over becomes?
Minus 1.
Minus 1. Do you need to flip the sign? Because there's a minus now?
No.
You memorize minus, then you flip the sign. Wrong. Only when you times or divide by -1, or when you are taking the reciprocal, or when you are those are the two main cases. So
Yeah.
so all other cases usually you just keep it as the same sign. Now negative 0.9 minus 1 is actually what? Negative 0.1. More than equals. Both sides got negative symbol. What do you do? Times -1.
Sign.
So then you get P of Z less than equal to 9. Positive 0.1. What happens to your symbol?
Must flip.
Less than equal now. Very good. So now you want to solve for Z. How? You must okay, wait. Let me read the question. You have a binomial 24, P. Okay, so let's take a look at the GC now. Clear. So what do we need to do? We need to go and again key in this P of Z less than equal to 9. Now it's in the correct format already. Random variable on the left, less than equal symbol in the middle, and a number on the right. So B for binom CDF. Then you can key in your N value, in this case 24. What's your P value?
X.
Don't know, right? It's just a P, so you put in X. Then X value must be
The 9.
yeah, 9. Okay, good. Key in the 9 as a paste, and then what do you get? Oh, you have to press second table. Sorry. Let me see if I can detach LCD. Yeah, okay, maybe does it help? Quite small. No choice. Anyways, what do we have? 60 and you get error. Oh no, what happened? Did I do something wrongly? Huh? What did I do wrongly?
It is all error.
Yeah. Why? We start at what value? 64. 60. What is this X representing? The unknown. What's the unknown here?
The probability.
P. Probability can only be less than
Less than 1. Less than or equal to 1.
Yes, correct. Okay, so over here, right, maybe we shouldn't draw a table. Instead, we should just draw the graph. And you realize it's a little bit, no, it's not a little bit, it's very, very slow. But yeah, it's finally done. Can you see the graph?
Yeah.
So then you have to draw an extra line. Let's say we draw in 0.9. Okay, hold on. How do I get it to stop? Oh, I need P of z less than or equal to 9, which is the graph that we have just drawn just now, the tiny little snake at the corner. But we need 0.1 here so that we can have the right hand side. And then we need to compare the graph. Then we try to find the intersection. Oh, so second, and then calc, and number 5 for intersect. So move left a bit until you get the curve. Like the y you see here is empty, right? Can you see? It's empty.
Yeah.
Don't when it's empty, it's very bad. That's very bad. You have to keep on moving to the left. So move. Of course, the x should be less than 1. That's why probability. So finally we get some value already. Doesn't matter because we are just finding intersection. You don't need to go left and right. We are not finding the root. Just random location, click, then go for a red one. Also got value for x and y. Then you click guess. Okay, just press enter. And then it's loading. Yellow color circle spinning, it's loading. It will eventually get the answer here. Intersection. Can you see the answer?
What cannot see. 0.5.
Yes, correct. 0.52641184. Okay. Can. Here we want it to be less than or equal to 0.1. So okay, I try and zoom in. Oh no, this is gonna take a while. Let me try and zoom in a bit. You know how to use zoom box, right?
Yeah.
Just to make a nicer graph. Oh my. Because you zoom in already, the quality will improve, then they will take a longer time to load. So I'm just gonna cheat a bit. Oh wow, it's so fast. Right. Because I'm using a calculator on a computer. Anyways, back. Now we have this. Can you see the intersection very clearly now? Right, the blue and the red. So the blue is representing the PZ less than or equal to 9. The red is representing y equals 0.1. We want the left-hand side to be less than or equal right-hand side. So that means we want the blue to be below the red. Is that clear? So that means that your P value, which we just found, I need to calculate again because we redraw. I cannot remember the number. Blue, red, enter, until eventually we get P 0.52641184. Then can you tell me what's the direction of this inequality? We want blue to be less than or equal to red. So blue below the red. More than equal or less than equal?
So it's less than.
Less than. So you want to consider x values that are towards the left half. So let me draw a quick sketch of the curve. You're telling me there is blue curve here, there is red curve here. This is x equals to 0.526, blah, blah, blah. You want the left half, where the left half has a blue that's
the
above
right
red.
one.
No, right? Very good. Should be the right one. Oh, the right half where the red is above, the blue is below. Blue less than or equal to red. So that means that the direction of inequality, if you want towards the right, it will be, look at the arrow. More than equal, less than equal?
More than equal.
More than or equals. Okay, then tell me then we can start answering the question. What did they ask? they asked us to, what was the question? Yeah, where's my question? I forget where's my question already. Here. So find the least value of P such that you get the inequality. Yeah, so then therefore least value of P is just the answer already. I actually don't need to think so hard about the inequality. But I hope you understand, right? When it's more than or equals, that's why they use the word least. Important point to take note over here is that P is the 0 is less than P is less than 1 equal. So that means that your graph scale for X must choose properly. Okay. Okay, now don't go beyond 1 to get a nice graph. Currently,
change the setting.
Yeah, in the window.
Okay.
Or zoom box. Okay, just play around. Okay, good. That's discussion. Let's move on. Next one. Correct. Then I don't go through. Which one is wrong? This one, part 3. What happened? Okay. How about part 1 and 2? Is it correct?
Yeah, the top part is correct. But sometimes like I say let X denote whatever, right? Sometimes it's wrong. Then will I still get the mark?
If you can get the right answer, you get an answer more. Intermediate working. If you define wrongly, will you get a mark? I'm not so sure.
Like I will say it like in a very weird way.
If you can still get the correct same working P x less than equal to 3, then okay.
Yeah.
X tilde B, okay, then that one is fine. If you define it wrongly, maybe you might be marked down. But proper way to define it, you need to mention the n value, right? Out of 50 weeks, you need to mention the n value out of the n. You also need to mention the X is number of whatever, number of the event.
Okay.
Yeah, this is the success. This English phrase you're writing here, which you can just copy from the question, will be the successful event. And then here you just write down the probability corresponding to that successful event. Must always have a number of. Then also just mention to be complete out of 50. Okay, let me read the question first. So question 9, according to the school rules, student who arrives at school after 8 a.m. considered late. During school year, a boy cycles to school on 5 days each week. On any given day, the probability that he arrives after 8 is 0.05%. Over a period of 10 weeks, calculate probability he is late on not more than 3 days. So x less than equal to 3, you got 50 and 0.05. Yep, okay, just use a GC. Part 2, over a period of 10 weeks, calculate the expected number of weeks that he is late on at least one of the days. Let me read our solution. So 1 minus 0.05 is 0.95, probability that he is on time. So 1 minus 0.95 to the power of 5. So it means that he is on time 5 times. Then you take 1 minus, so the complement. So he's never on time. Sorry, no. He is at least on time. He's on time at least 1 time. Then you get that 0.22. Okay, so let Y denote the number of weeks where he is late on at least one of the days over the 10-week period. Oh, sorry, 0.95 is probability that he is on time. Right. Then 1 minus 0.95 power 5 means at least 1 time he is not on time. He's late. Okay. Then Y represents number of weeks, so binomial, then 10 for the number of over a period of 10 weeks, then the probability which you calculated 0.22. Then expectation is just NP. Okay, good. Then part 3, sorry, mic test, are we still?
Yeah.
Are you still there? Okay, good. Now for part 3, when the boy has cycled to school for the nth time, Probability that he arrived at school late at least once is greater than 0.5. Calculate the least value of n. So let's see denote number of days the boy is late over n days. At least once. Cycle to school for the nth time, so that means there are n independent trials. Then probability that he arrived at school late at least once is greater than 0.5. So arrive at school late at least once. So that means you want the number of times that he is late to be more than or equals to 1. So we just want to find P of Z more than or equals to 1. Well, what's the value of P? You want this to be more than or equals to 0.5. What's the value of P? What does Z represent? The event where the boy cycles to school and he arrives at school late.
Yeah.
Actually, let me think of it. Let me take a look at the solution. Sorry, give me a second to download this. What question is this again? Question 9. Okay. So it should be 0. Oh, it's just 0.05. Right. That was at the beginning of the question. Oh. Denote number of days. W denotes number of days the boy is late over a period of n days. So you see they always mention over something. Over a period of n days. So that you can give a full explanation of that random variable. Must mention the n. The event here is number of days the boy is late. Number of what thing? Number of days of what thing? Of the event where the boy is late. So the boy is late just 0.05, 5% probability. Okay, then your answer, let's just read the solution. Then in this case, it will just be n comma 0.05. Then we want the least value of n so that this one more than or equals to 1 is more than 0.5. Right? Because they mentioned they cycle n times, late at least once, so more than or equals to 1 here, and greater than 0.5, so more than 0.5 here. Okay?
Yeah.
Okay, good. So now you want to solve this. What do you do? Straight away, when you see more than equals or binomial, what do you want to do? Convert into less than equal. How? 1 minus. 1 minus. So 1 minus of the opposite, which will be W, strictly less than 1. Opposite of more than equal is actually just strictly less than. Right? Then what is strictly less than? It's just exactly equal to 0. Okay?
Okay.
Then now you can solve for PW equal to 0. It will just be less than 0.5. Is this part clear?
Yeah.
I'll just make PW equals 0 the subject. Then after that, you can use the binomial formula. They try to do it manually, the algebraic method. Actually, using a GC, you can just key in the calculator. Oh, by the way, PW equal to 0 is 0.95 power n. That's from the formula list, MF26. Okay? You can get this from MF26. Let me show you.
Okay.
Copy and paste. Okay. Okay, this is just the PW exactly equal to 0, right? So that's your capital X change to a capital W. Your little x change to a W, change to a 0. Okay, so this is actually just n in this case is just n, x in this case is 0, sub in p with 0.05 raised to the power of x in this case is 0, then 1 minus 0.05, so 0.95 to the power of n minus x, which is n minus 0. N choose 0 is 1, anything power 0 is 1, n minus 0 is just n, so you're just left with 0.95 to the power of n. Is that clear?
Yeah.
Okay, very good. But actually, there is an even better way. PW equals 0 less than 0.5. You can just use GC. Let me show you. So, clear. P, right? Sorry. PW equals to 0, right? Equals. You see the equal sign here?
Yeah.
So if it's equal, you can just go for, instead of CDF, you go for PDF. Okay, PDF. So number of trials in this case is variable x. P value is 0.05. Mic test, can you hear me?
Can.
Okay, good. Then the x value here in this case is just some variable. No, the x value here is just 0. Yeah, W equals 0. Okay. Then you just paste it. Then you just second table. And you get all these values. So you need, it's actually what you realize is that all these values of y it's just 0.95 to the power of some value of n. 0.95 power 60, 0.95 power 61, 0.95 power 62. But if you know how to use the GC, you don't even need to know that PW equals 0 equals 0.95 to the power of n. Okay, yeah, this is GC style. Then you want less than 0.5. So I noticed that the value is decreasing, so I should probably start from a smaller value. Let's just start from like 20. Then second table. Less than 0.5. Okay, it's still quite small. So we start even smaller. Let's just start from 1. Okay, here is bigger than 0.5. You need it to be less than 0.5. So just keep scrolling, and finally we reach the answer. Can you see it's 14?
Yeah, can.
13 is 0.513, 14, 0.487. So I spare you from the misery. I'm just going to tell you that. I'm just gonna explain the answer verbally. It's just 14. Okay? This value of n. Okay, good. That is part 3. Let's see what's the next part we want to talk about? Oh, do you need me to explain the algebraic method?
It's just take like log on both sides, right?
Correct. And then notice the symbol change direction. Because LG 0.95 is negative, you divided by negative.
So I have to check manually.
Yes. And you should already know this from O level as well. Y equals to logarithm of whatever base ax, where a is more than 1. It will always pass through 1, 0. So whatever value here, if you take log of LG is just log base 10 of 0.95, it means your x value here is 0.95, right? Can you see the 0.95? Then its corresponding y value is what? It's below the x-axis. When your input to log is less than 1 or more than 0 to make sure it's defined, you will get a negative value for the log. Yeah, so without using a calculator, I already know it's less than 0, negative. Okay.
So less than 1 is negative.
Yeah, LG or something less than 1 is negative. Yes, of course.
Okay.
Okay. Can. No wrong file. Let me look at your worksheet. Which still the wrong worksheet. Oh my goodness. This one. Yes. Okay, this one explained already,
Yeah.
Okay, carry on. Question 10. Question 10, part 2 and part 3. Okay, let's just read the question. Female doctor wishes to test a new treatment for a certain disease. She asks patients who come to our clinic suffering from this disease if they are willing to take part in a trial. Based on past experiences, she finds that the probability of such a patient willing to take part is 0.3. Willing. She showed that the probability that at least 2 patients are willing to take part in this trial when she has asked 8 patients is 0.745. Correct to 3SF. What assumptions do you have to make to justify the use of the distribution in your working? Next, we random variable denoting number of patients willing to take part in the trial out of 8 patients. So 8 patients and willing is 0.3. X more than equal to 2 means at least 2 patients. Then just 1 minus, then you flip it around, less than equal to 1. Okay, then subtract and you get the probability 0.745. So you use binomial distribution, agrees to go for the first trial. For the trial has to be independent from whether another patient decides to go for the trial. Probability that a patient agrees for the trial stays constant at 0.3 for all 8 patients. Correct. Good. Okay. Now part 2. The doctor decides to ask n patients. Find the least number of patients she has to ask so that she will have a probability of more than 0.8 that at least 2 patients are willing to take part in this trial. Decides to ask n patients. So that's probably the number of trials. Each attempt that she asks is 1 trial. There are n trials. And you want to find the least number of patients she has to ask so that she will have a probability of more than 0.8. The 0.8 here is actually talking about P of the Q. What is it? At least 2. Probably number of patients here, so more than or equal to 2. You want this to be more than 0.8. Does this make sense?
Yeah.
The probability P of whatever is more than 0.8. More than means you don't have the equal sign. Then at least 2 patients. So here, more than equals 2 in the event. All right. Yeah. So what do you do straight away when you have a more than equals? Convert
Change
into
less than or equal to.
how? What
Okay,
exactly do you write down now?
is 1 minus Q
P
less
of
than or equal to 1.
very good. More than 0.8. Solve.
Oh, then bring over the 1.
And you
then
get
negative 0.2.
then -1 I multiply on both sides. So I get
and
positive
change the sign.
sign. So minus to plus. Okay. What do you mean change the sign?
Change to less than or equal to. Less than.
No, just less than. When you multiply, you flip. More than become less than. Don't introduce an equal on your own. So now you just need to use GC. So let's see. So less than equal to 1. Just go y equals clear. What's the random variable? N comma 0.8. So second distribution, we can go to CDF. N in this case is X. P in this case is 0. It's not. Is it 0.8? Wait, hold on. Q denote number of patients willing to take part in the trial out of and students. How come got students? Should be patients.
Oh, yeah. Oops.
Yeah. Wait, actually I have to be a bit more careful. Let me read carefully first. These number of patients she has to ask so that she will have a probability of more than 0.8 that at least 2 patients are willing to take part in this trial. I think it should be using the probability 0.745 here. Right?
Oh.
Eh? I'm a bit confused already. Let me just look at the solution. Oh, 0.3. Hold on. A patient is willing to take part in 0.3. Right. Sorry. It's always the start of the question. Sorry, can I just have a 2-minute break?
Yeah, sure.
I'll be back.
Okay.
2 minutes. Hello.
Yeah.
Yeah. Okay. Sorry, I didn't read carefully. Yeah. So here we are looking for we're looking at n patients, and you want the least number of patients you have to ask. So just form an inequality involving the n, so that you will have a probability of more than 0.8 that at least 2 patients are willing to take part in this trial. So you define the random variable correctly, q, and you want q to be more than or equals to 2. So you have a probability of more than 0.8 that these 2 patients are willing to take part in the trial. So this willing to take part in this trial means you only want to, when you're setting up your random variable q, tilde b and n comma p, your p value should be the probability for one such patient being willing to attend. And in this case, that probability is 0.3, as stated at the start. Such a patient willing to take part is 0.3. Okay, so yeah, just change that 0.8 over here into 0.3. Okay, here. Can now?
Okay.
Okay, good. So now that we know this is 0.3, we can just use the GC. Okay, so back to GC. Let's take a look. We are trying to calculate the binom CDF now. So random variable is the number of trials n. Then p value is 0.3. Yeah, 0.3, and then x value is a 1. Then you paste. And you need this to be less than 0.2. So maybe we can also key in 0.2. Oh. Okay, then here, since we're only interested in the 0.2, we can change our scale as well. Just not second. Just press the window button. And then your Y scale, you change it to maybe, you don't even need the negative. So negative 0.1. And here you change it to 0.3. Maybe, for example. And then your X, you can let it be as big as you want, maybe 50. And you can draw the graph. Okay.
Okay.
Oh, right, the graph doesn't work out. Because this is discrete values. Okay, never mind, just draw second table again. Okay, you let me just get rid of my Y2. Sorry. Clear this. You don't need Y2. You just need a second table. So you want probability such that this such that the left hand side is less than 0.2. So you just keep on scrolling down until you find a value that's less than 0.2 the first time. 0.255 becomes 1.196. So that's the first occurrence where it becomes less than 0.2, which is when x is equal to 9. In other words, n equals to 9 is your final answer. Is that okay?
Yeah.
Okay, good. I just copy down some of the values. So n here, then p of q less than equals to 1. Then you just copy down some numbers. 9 is 0.196. 8 is something 0.25529. Yeah. Then the moment you increase it to 9, the probability becomes less than 0.2, and therefore that value of n equals to 9 is your answer. Okay, now part 3. Find the most likely. Most likely just means expected value or highest probability. A bit vague, but I think this should mean highest probability. Find the most likely number of patients who are willing to take part in this trial when she asked 9 patients. Let's just look at the solution then. A bit vague because most likely can either mean expected number, or it can mean the highest probability of whatever event they are talking about.
Oh.
Okay. Oh, here is highest probability lah, huh? Here we have 9. We define a new random variable, but the n is equal to 9. Oh, sorry. No. Oh my goodness. You're just using the same random variable as your part 2, but you replace the n with a 9. Okay? Then after that, you just need to look at all the table, the distribution. Look at the distribution. So what this means is you have a table of values, right? When n is equal to 9, it means that you have a table like little y, then p of capital Y equals to little y. And this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And each of them will have a certain probability. Okay? Then we are looking among all these probabilities, the highest guys. We realize these two are the highest. And they have a tie. So in that case, we will answer what is the most likely number. It will be the 2 and the 3. But the question is, how do we generate all these numbers? How do we generate all these numbers?
The binom PDF.
Yes, correct. Binom PDF. So let's take a look. So y equals just second table. In this case, it's binom PDF. Yes, second distribution. Then go to binom PDF. What's your number of trials? 9 patients. What's your p-value? 0.3. Then in this case, what is your x value? You want it to be a variable. So you can take on all the possible values 0 to 9. Then you paste it. Then second table. You notice that the moment it goes beyond 9, 10 onwards, it just gives you 0. This makes sense, because you only trial 9 people. Beyond that, it doesn't. There are 10 people, the probability is impossible. That's why it's 0. Likewise, for the cases where it's less than 0. Okay, I need to second table set first. Let's say I go from -2. Oh, you see, -2, -1, it will just give you 0. But from 0 onwards, it will give you some positive number. Okay, all these positive numbers. Just look out for the guys that are the highest. You'll realize it's these two. So if this is an extra question, but so what you realize is that you can actually draw a graph like this. Y-axis representing P of Y equals to Y. Then this represents Y, let's say YI. And I index will be 0, 1, 2. Then it means that we can actually draw a bunch of vertical lines to represent the height of the probabilities. Oh, this is 0, 1, 2. Maybe I'll just call this index I. 1, 2, 3. And then after that, it just keeps on decreasing. Dot, dot, dot. It's an incomplete graph. Okay. So you notice there's a curve. Doesn't it look like a certain shape, you know? A bell curve, right?
Yeah.
If you increase the n value to a big enough number, in this case, in H2, it's n more than 30, you will be able to approximate it as a normal distribution. Okay, using what theorem?
Central limit theorem.
Yeah, CLT. It will approach that normal distribution, the limiting distribution. Yeah, the limiting distribution will become a normal distribution. You approach it in the limit. So you need to let n go to infinity, technically. But here in H2, we can assume that n more than 30 is big enough for you to approximate it as a normal distribution. The mean, at least. Okay, Ken. So in distribution. In the limit. Okay. Yeah, so anyways, you find the highest probability value and the corresponding y value that makes it happen. Then those are your most likely numbers. Okay, then for part 4, just find the average n times p. Expected number. Okay.
Can.
All right, Ken. Continue. I try to finish this paper. Okay. Let's see. No. Okay, question 12, part 2. In a large population, the proportion having a blood group A is 35%. Recipients of blood from the first 5 people attending a clinic are to be tested. Can be assumed that these 5 people are a random sample from the population. Random variable denotes the number of people in the sample who are found to have blood group A. Show that P x n equal to 2 is equal to 0.765. So you are testing 5 people. The success event is when you do have blood group A, 0.35, 35%. So x less than equal to 2 means less than or equal to 2 people have blood type A among these 5 out of the 5 trials, out of the 5 people. Then this will be just use binom CDF and you can get the answer. Part 2, there's part A and part B. 4 such samples of 5 people are taken. Find the probability that 3 of these samples each have more than 2 people with blood group A. 3 of these samples each have more than 2 people with blood group A. So 4 such samples of 5 people means what? 1 circle inside got 5 people. Okay, that's 1 sample. Then you times 4. Does it make sense?
Yeah.
Sorry. Sorry, let me use. Can I use the toilet for like maybe 5 minutes? Sorry.
Yeah, sure.
Sorry. test, mic test.
Yeah.
Mic test. Sorry for the delay. I know it's quite late. Sorry, let's try and finish this. Is that okay?
Can.
Can okay. So what we have now is 4 such samples. That means that n should be equals to 4 in this new variable, not 20. I know 4 times 5 is 20, but you just want, you see, part A, they're asking you 3 of these samples. Okay, 3 of these samples, which means what? Which means you need Q to be equals to 3. Does it make sense?
Yeah.
Then here the event is actually what? The success event is actually here. Is everything is actually a binomial. This is a type of problem known as binomial inside a binomial. So here the successful event is actually what? Each person have more than 2 people. Sorry. Each group of 5 sample have more than 2 people with blood group A. Here in part A, we found out less than or equal to 2 means 2 or less people. Here we want more than 2. More than 2 means what? Strictly more than 2, which is equivalent to, i.e. Sorry. More than 2 means, more than 2 means more than 2 like this, i.e. more than or equals to 3. Okay?
Yeah.
How do you link less than equal to 2 to more than equal to 3? Each sample. So it's actually using the random variable x, right? X represents in the sample, so 1 sample. So what would it be? This means that your Q here, you don't use that probability. Wrong. 20 also wrong. Oh, you're using number of people out of 20. Wrong also, because it's not answering the question. They're asking for how 3 of these samples. So you should be number of samples, where each sample has 5 people in it. That have blood group A also not so accurate. It should be that each have whole thing wrong. That each have, just copy the phrase. Each have more than 2 people with blood group A. So what is this probability? This probability over here is actually just P of what? P of x more than equals to 3. How do you link it to x less than or equal to 2? It's really just 1 minus P of x less than or equals to 2. Right?
Yeah.
You see that? So your answer for the probability is actually just 1 minus 0.76463 or 83. I can't tell your handwriting. Never mind, we calculate it. Let's see. So we have n is 5, p is 35%, 0.35. Then x value is 2, key that in. Then you have second left, second insert 1 minus equals 0.235. Yeah, okay. Never mind, we can just key this in the GC ourselves, right? So we'll just get 0.23516. Oh. Then after that, not 20 anymore, because we want to focus on number of samples. In this case, how many samples are we taking? How many samples each of which with 5 people are we taking?
3.
Wrong. Read the part that came before. That's what we want. That's what we want. We want 3. We want only 3. But how many samples did we actually take?
4.
4. So that means here should be a 4. Okay? I must read the question carefully. 4 such samples, that's why it's a 4. Then we only want 3 of them. Also Q equal to 3. So that means at the end of the day, what we are really asking you to find is probability of this new random variable Q, which is the number of samples out of 4. Out of 4, sorry, I forgot to mention this out of 4. Where each sample is the group of 5 people. And you want these number of samples each have more than 2 people with blood group A. So you have like 4 samples. This one, 1, 2, 3, and 4. So within each sample, some have like, let's say 3 people with blood group A. This one has 1 person with blood group A. This one has 2 persons with blood group A. This one has all 4 people with blood group A. So in that case, how many samples do we have in this example with more than 2 people having blood group A? How many samples have more than 2 people with blood group A? Here 2 have, here 4 have, here 3 have, here 1 have. So how many samples are there that have? There are 4 samples total. Among these 4, how many of these samples contain a circle, a group of 5, such that there are such that each have more than 2 people with blood group A?
2.
Wait, I draw a picture. Okay, wait. N equals to 4 samples, each with 5 little tiny humans. I put a tick to represent a person who does have blood group A. This one, how many ticks do you see? 1.
One.
This one, how many ticks you see? 3, 2, 4. Each. So within one group, the tick represents the number of people that have blood group A. 1, 2, 3, 4, 5 people. One single tick means 1 person in this group of 5, in this one sample group of 5, have a blood group A. This guy, how many people have blood group A in this sample?
3.
This one?
2.
This one?
4.
Okay, so now I ask you again. Within this sample of 4 groups, each containing 5 people, how many samples have more than 2 people with blood group A?
Why is it not 2?
Wait, more than 2. Oh, right. Sorry, I am being very blur now. You are correct. More than 2 is, I was thinking of more than or equals to 2. Maybe I shouldn't conduct lessons so late into the night. These 2
Yeah.
okay. Sorry. Yes, you're correct. Oh my goodness. Yeah, these 2, 3 and 4 is strictly more than 2. But if it's more than or equal to 2, it will include the 2. I was thinking of that, but no, this is wrong. Okay, so you understand. Then we can proceed. So what they're asking you to find out is what? P of Q exactly equal to 3. Yeah, P of Q equal to 3. That's all. That's all.
So I
Okay.
use the PDF.
PDF. Yes, correct. The PDF. Binom PDF. Yes, the particular value. Or you could count it manually also. Okay. Then trials is 4. Then the probability, just key in the 0.2356. 516. Then Q equal to 3. Okay. Then that's your answer. 0.039785. So round off 3SF. 0.0398. Yeah, that was for part A only. Now for part B, find the probability that the first 3 of these 4 samples has exactly 2 people with blood group A, given that the total number from these 4 samples having blood group A is 9. So you see the word given here. Straight away, you know what kind of probability are we dealing with?
Conditional.
Conditional. So let's just call this condition. Green color, we call it event B. Then what is the probability we're interested in is the, what is it? First 3 of these 4 samples each have exactly 2 people with blood group A. Let's call that event A. Then we're gonna find P of A given B, which is really just P of A intersect B, P and B divided by P of B. Okay, so how do you find P of A intersect B? Let's think about it. In terms of the English, the logic. First 3 of these 4 samples each has exactly 2 people with blood group A. So let's just draw a bunch of circles. Okay, so first 3, 2 people, 2 people, 2 people, has exactly 2 people with blood group A. Given that the total N combined with event B, the total number from these 4 samples having blood group A is 9. Total number from these 4 samples having blood group A is 9. So if you already have 2, 2, and 2 in 3 of those samples, that's a total of 6. But you have a total of 9. So that means there's 9 minus 6, which is 3 more people having blood group A at where? At the last remaining group. No choice. That's the only way you can form 9.
Oh.
Right? That's what it means. Here I'm considering what is A intersect B. The yellow intersect with the green. I must think through it logically. Just read the story and try to understand. First 3 of these 4 samples each has exactly 2 people with blood group A. So I selected these 3 as the first 3 groups. 2 ticks, 2 ticks, 2 ticks. So 2 people with blood group A, 2 people with blood group A, 2 people with blood group A. Total is 2 plus 2 plus 2, which is 6 people with blood group A. And event B, intersect with B, right? So and B, so combined together with B, overlapping with event B. Event B says total number from these 4 samples having blood group A is 9. So that means you have 2 plus 2 plus 2 plus X must be equal to 9. That means X equals to 3. Okay? 2 plus 2 plus 2 plus 3 will give you 9. Is that okay? Good. So how do you find this probability? 2 people having blood group A, 2 people having blood group A, 2 people having blood group A, and 3 people having blood group A. First 3 of these 4. So that means the probability of one person having blood group A is 0.35, right? So doesn't that just mean it's just 0.35 to the power of 2 here? And then you just have to, actually, can you just raise it to the power? I'm very tempted to just raise it to the power of 6. 2 plus 2 plus 2. Or maybe just power 9. Is it that simple? First 3 of these 4. Okay, I think it's better if I just go into the solution. It's taking too long. Let's just see. What did they say? See, they concluded it must be two people with blood group A in each of the first 3 samples and 3 people with blood group A in the last sample. Right. So it's X equal to 2 power 3, then X equal to 3. Right, where X is what? X is the very beginning, the variable. Oh, X equal to 2. Okay, so there are actually, this one P of X equal to 2, not that simple. It's actually among 5 people, you want to choose 2 people to have blood group A, right? And then you calculate the probability from those 2 people, which is rather long-winded. It's just binomial PDF formula. So in that case, we can just use the formula P of x equal to 2 and then raise it power 3. You can use a GC. Likewise, for P of x equal to 3, that's 3 people having blood group A in the last sample. Then you just divide by Z equals to 9. What's Z here in this case? Here they combine into 20 people already. Because what is Z? What is the Z in this question? It is my version of B, event B, which is the green color part. What does green color part refer to? Total number from these 4 samples having blood group A is 9. Oh, so they already mentioned total number. So that means that we can just calculate in, you can just consider binomial distribution in terms of total number of people. And then compare with total number having blood group A. So that's why they introduced a new random variable where this guy is the total number of people. Then it's just 35% chance having blood group A. Okay, good. So yeah, then you just have to consider this binomial random variable and then just calculate P of Z equals to 9. Right, 9 people having blood group A. Then just divide and you get your answer. Is that okay?
Okay.
Can. Okay, let's see. Any more questions? Oh no, still have 14. And a differentiation one. Okay. Did I go through the differentiation question? Feel like I did. Did you ask me this question?
No.
No? Oh, okay. Can. Let's try and finish up. Circuit board. Was it not you who asked me this question? Can't remember. Okay. Never do the whole thing. Let's just try the question. Okay, let's just read the question first. So factory A produces circuit boards which have a defective rate of 2%. Okay, in an attempt to reduce the defective rate to 0, the factory employed additional workers to test all their circuit boards in order to remove the defective products. Each such worker is paid $10 a day to test exactly 400 circuit boards. In addition, for each defective circuit board found, the worker is paid an extra $5. A worker works for 5 days in the week. Find his expected salary and variance in salary for the week. So let's look at the solution. You let X denote the number of defective circuit boards found after working for 5 days. That's a random variable. They didn't mention random variable, but to be more perfect, it should be, say, let X denote the random variable for the number of. Okay, but anyways, that is also acceptable. Don't need to say RV. Number of circuit boards tested would just be by ratio, by rate. If you do test 400 a day, then you just times 5 to get the total over 5 days, right? So that means that the number of so this worker sorry, let me see. Maybe I should also qualify this found by one worker, right? So that we can know the rate nicely. All right, it should be more precise by one worker. If not 2 workers, then you have to double the number of circuit boards, which is not what we are interested in. We just want the probability for one worker first. So yeah, that means that you have that one worker, he will be testing 2,000 of these circuit boards over 1 week, or at least over 5 days. Then the probability of finding a defective one is 0.02. Why is that so? Because over here, 2%. Is that clear so far?
Yeah.
Okay, good. Then you let S denote the salary of the worker for the week. Okay, can. Then in this case, what would it be? We know that this salary must be some function of the number of the number of days that you work plus the number of defective circuit boards that you find, because you earn an extra $5 per circuit board you find that is wrong. So in this case, if X is the number of defective circuit boards, you can just times 5. Oh, that's why you have a 5X here to get the total extra bonus you find that you earn from finding the mistakes. And then this is plus 50 is a standard salary. It's a fixed salary. $10 a day. We work for 5 days, so just times 5, $50. So that will be our total salary. Then how do you find expectation and variance? Just use the formula. So expectation of S equal 5x plus 50. What do? You just have to substitute in the S with 5x plus 50, linearity. So you can split it out as expectation of 5x plus expectation of 50. 50 is a constant, so leave it alone. Drop the expectation. But you have a 5 in front of the x, you can bring it out in front. So factor out. Take out. Then you're left with 5 times e power. Sorry, not e power. 5 times expectation of x. This part, okay?
Yeah.
Then expectation of x is what? Here, x is just n and p. So expectation is memorize the formula np. Okay? So substitute in n and p. All right, then after that, you just add on the 50 and you get your final answer, 250. Okay?
Yeah.
Then for variance, variance, just same thing again. You got a sum. So what happens when you have a constant over here? Does it affect the variance?
No.
No, so you can just ignore it, drop it. So that means this is just equals to variance of 5x. This is just equals to variance of 5x. Then what happens when you have variance of 5x? The 5 can factor out, you're left with 5 squared times variance x. Now remember the square, variance ax is a squared times variance x. Then 5 squared is 25, leave that alone. Then variance of x, can we find that? What's the formula?
NP1 minus P.
NPQ. So 2000 times 0.02 times 1 minus 0.02, which is 0.98. 0.98. Don't forget the 25 in front. Multiply and you get 980. Okay, can.
Yeah.
Good. A part 1 done. Next, A part 2. Find the probability that the worker earns at least $250 in the week. So salary is over here. You want how much he earns, the salary, at least $250 in the week, the 5-day work week. So you need to find S more than 250 probability. Is that clear?
Yeah.
That's at least so should have an equal. Sorry, forgot to mention the equal. Okay. Okay, good. Then in that case, you can just substitute the S with the 250. Okay. Then you get 5x plus 50 more than equals 250. This part, is it okay?
Yeah.
Can all right, good. Then after that, what do you do when you have a 5x plus 50 on the left hand side? You cannot leave it alone. Remember, whenever you want to key in calculator probability, you must make sure it's in a what format?
The less
Key
than
bracket.
50.
Random variable on the left. Okay, the capital letter random variable must be on the left as well, not just less than equal. The random variable on the left. Then the number on the right. And the random variable on the left, I gave you the formula was px less than equals some happy face. Here is just a single x. Right? Here you got a 5x. Is it okay to just key in the calculator straight away? No. You need to simplify a bit more. It's sort of like solving for x, but in an inequality. So let's just do it at the side. 5x plus 50 more than equal to 50. You can subtract 50 on both sides. What do you get? 50, 50 cancel off. You're left with 5x on the left. 250 minus 50, you're left with 200 on the right. Now solve for x. Divide by 5. Then you're left with 40. Do you need to flip the sign? Divide by 5?
No.
Don't need because positive value 5. So now you're left with x more than equal to 40. Okay? Are we done? Still not done because now we need to make sure it's less than or equal. So 1 minus less than equal 39. Not 40, must be 39. Okay? Because 40 more than equal 40 starts from 40 and counts upwards all the way. 40, 41, 42, 43. So 1 minus, you must get rid of the ones that are not 40, 41, 42, 43, which must be 39 and counting downwards. Okay, and then you can just key this in the GC and you'll get your final answer. Do you need me to show you the GC?
No need.
Okay, can. Now let's move on. 13 part B, let's see. So find the smallest number of days and for which a worker needs to work in order for his probability to earn at least $500 to be at least 90%. So a lot of things going on, right? Can you see? This is actually what we call, I already mentioned this, binomial inside a binomial kind of question. Okay, can you tell me what is a new random variable you should define?
Um.
Can you tell?
No.
No? Okay, can. In this case, let's just read this. Find the smallest number of days n for which a worker needs to work in order for his probability to earn at least $500 to be at least 90%. Actually, let me think a bit. I'm trying to see how I can hint to you the answer. Okay, because we now have n days, right? N days instead of 5 days. So that means that we should just have the exact same sentence for the random variable, but we just use a different letter and change the 5 to an n. Does that make sense? As a first step.
Oh no.
No. Okay, so let me bring up the screen. Okay. Okay, so nope, please close that. What is it? Okay, how do I make this more intuitive? I mean, like this. You see, X denotes number of defective circuit boards after working for 5 days. So now we change it to n days, right? So that means we should also naturally change the 5 into a n.
Oh.
Right?
Yeah.
Just recycling the information. So we should let y denote the number of defective boards found after working for n days over here. Okay, so we are going to do the exact same procedure, but just change the 5 to an n. Okay, just change the 5 to an n. Then that means that we are going to have number of circuit boards tested, a rate question, 400 per day, but you have 5 days, so times 5. But now it's 400 per day, but you have n days, so times n, 400n. Okay. Then now we need a binomial. We know that it's a binomial random variable again. Previously we had what? Previously we had multiplying and we get the total number of boards tested. Now we also multiply, then we will get the total number of boards tested, 400n. Probability is still 0.02 of getting one particular circuit board to be 42% chance. If you remember the question, effective rate of 2%. Oh, do you see it's the exact same thing?
Yeah.
Just changing the 5 to an n, okay, and changing x to y. Okay, then now we want to find the salary, but this time it's actually this one I realized it's not a binomial and binomial. I told you that at the start. Sorry, I was confused. Yeah, so over here we have S denote the salary of the worker for the week. So here we still need the same thing, but we need to change it to n days, and that's why we use a new letter S2, a new subscript S2 to make it different from the original. So now this S2 will just be what? It will just be the original fixed salary. If you work for n days, you have $10 per day. But then if you find a mistake, each mistake you find, which is y number of mistakes, you can earn $5, so times 5. So this will be your total salary. Is that okay?
Yeah.
Okay, good. So now total salary S2 is found, but updated to have N days. So Y and N here. We want the smallest number of days so that this new guy's salary is now what? If we read the question, this new guy's salary is to earn at least $500. You need that probability to be at least 90%, 0.9. So that just means the following. P of the new salary S2 must be more than or equals to 500, minimum $500 earnings. And you want it to be more than 90%, 0.9. Where? Yeah, at least 90%, so 0.9. 90 over 100 is 0.9. So more than equals to 0.9. Is this part okay? We want the salary to be at least $500. So S2, sorry, more than equals 500. Then the probability of this, you want it to exceed 90%.
Yeah.
Just
Okay.
translating English into math, right?
Mm.
Okay, good. So now you can solve. What do we know is S3? Sorry. What am I doing? Yeah. I'm going to part C. Sorry. Is that why you're confused?
Yeah.
Sorry, it should be S2. Oh my goodness. S2, just replace it with 5y plus 10n. Oh my goodness. Yes, this one. Oh, sorry. Looks so similar, but it's S3, not. We want to focus on S2 first, part B. Sorry. S2 more than equal 500. Replace the S2 with 5y plus 10n. Then what do we need to do now? Which one is a random variable here, y or n?
Y.
Y. So what do you need to do? Make y the subject, okay? So maybe I show some working. 5y plus 10n more than or equals to 500. Then you can subtract both sides with 10n. So more than equals to 500 minus 10n. Then y more than equals to divide by 500. So 500 minus 10n divided by 5. Just algebra lah. Then you simplify it into 100 minus 2n. You can factor out of 5, then you get 5 bracket 100 minus 2n over 5. Anything to cancel? Yes, the 5 cancels off. You're left with 100 minus 2n. So y more than equals 100 minus 2n over here. Okay, then how? Well, how do you proceed? This y is actually what? Again, it's a discrete random variable. This entire topic is binomial, so it's always discrete. Then y is more than equals to 100 minus 2n. What do you need to do when you have more than equals?
Must change to less than equal.
Also, it's a 1y already, so it's fine. We can now change it to 1 minus. 1 minus what? What would it be? So you draw a number line if you are confused. Here is 100 minus 2n. We have y more than or equal, so shade in the circle towards the left. We want to subtract away 1 minus, so all the others, the complement of this will be empty circle, then towards the left. So in other words, 1 minus p of y strictly less than 100 minus 2n. 1 minus p of y strictly less than 100 minus 2n. But because y is discrete, y less than 100 minus 2n just means you need to do what? Like maybe if it's too complicated, let me use some actual concrete numbers. Y more than equals to 10. P of y more than equal to 10 is the same as 1 minus p of y strictly less than 10, which is equivalent to what? 1 of p minus, 1 minus p of y strictly less than or equal to
9.
Less than or equal to 9. How do you go from 10 to 9?
Minus 1.
So that's exactly what we're doing here. 100 minus 2n, you have to minus 1. Yes, so maybe I write down over here, minus 1. That's why you have 100 minus 2n become 99 minus 2n. Is that okay?
Yeah.
This part okay? Good. More than equals 0.9 doesn't change, just copy and paste all the way. Then now you need to make this guy the subject. How? 1 bring over, you get minus 1. 0.9 minus 1, negative 0.1. Okay, maybe I cancel this off, then I cancel this off, and I put down negative 0.1. Now, negative on both sides, what do? Times -1. What happens to your inequality symbol? Flip it around. Clear so far?
Yeah.
Good. So now how do you solve this? You have to use the table of values for y. They already gave you the instruction. Let me show you how to key this in. So you have to be clear of who's the variable here. N is the variable. So you want to use second table. So again, just y equals. It's P of y less than equal, so it's binom CDF. CDF. Go here. Second distribution, then P for binom CDF. What's your number of trials for y? Right, the random variable we're dealing with now is y. The random variable we're dealing with now is y. Over here, random variable is y. Look, what's your number of trials?
400 N.
So on your GC, you cannot type n, so you type 400. What? X. Okay, then P.
0.02.
0.02. That's just beside n comma p. Two values here. N comma p. Just 0.02. Then how about x value? Less than or equal to?
99 minus 2N.
So 99 minus 2.
X.
There's no n, so 2x. So there's a variable on both places. That's why this question has an asterisk, a bit more difficult. Okay, and then after that, second table, and then you get this table of values. What do you want to do? You want less than equals 0.1. So just go down, and you realize, wow, it's gonna take quite a while. Actually, not that bad, because there was a sudden jump here. 0.8, then become 0.4, then 0.1, then 0.01. Okay, and then what's your answer?
12.
12. So therefore, your smallest value of n is now 12. Okay.
Yeah.
Good. Yes. Maybe they already drew the table for you. The table of values. Here, they just draw two of the rows to show you. When n is 11, this you submit n with 11, whatever it is, the calculator will calculate it for you, the p of y. Less than equals whatever. Then you get 0.12793. Is it less than equals 0.1?
No.
Is it less than equals? No, it is not. So that means that you have to go on to the next value of n, which is 12. And you realize luckily it is less than or equals to 0.1. At that place, you stop and you conclude your final answer is 12. When you notice this guy is less than equal to 0.1, then you stop. N equal to 12 is your answer. Can? Okay, moving on. Good. Then 12 part C. A competitor factory B produces circuit boards which have a defective rate of P%. It also employs workers to test their products, paying them in the same way as in factory A. Factory B promises workers a 90% chance of earning at least $500 in 5 days. Find the minimum value of P for this to be true. Okay, let's just read the solution now. For part C, let D denote the number of defective circuit boards found after working at factory B for 5 days. So in this case, it will be 2,000 number of trials, because you're just checking 400 circuit boards in 1 day. So 5 days you just have to times 5. Maybe should I write this down? 1 day 400 circuit boards. Then 5 days it will be 400 circuit boards for you times 5, which is 2,000. Okay, can. So denote the number of defective circuit boards found after working at factory B for 5 days. So we found out that there's 2,000 circuit boards you're checking for one worker at least. Then the probability is P%. This is also in factory B, not A. Okay, so now we want to calculate the salary again. who work 5 days at factory B, right? Because in 13 part C, we are interested in their claim. The factory B says a promised worker 90% chance of earning at least 500. So we are focusing on this earning at least 500 statement. Then we create a random variable to help us to analyze this. And in this case, that would be just the salary. So it's again the same as part A and part B. Oh, is it clear? So S3 equal to 5D plus 50. What's 5D? $5 compensation for each circuit board you with a defective, with something defective that you found. Then add on the base salary $50. Sorry, it's not just sorry, this one need a bit of explanation. It's not just 50 straight away. It's $10 per day, and we are discussing about 5 days. So times 5 to get your total salary for 5 days. 10 times 5. Okay, this part okay, S3. Then now we want to find the read the question again. What did they tell us to do? They want us to check this claim that factory B promises workers a 90% chance of earning at least $500 in 5 days. Okay, just copy and paste the question here for reference, so I don't need to keep scrolling. You want 90% chance, so that means here is 0.9. Earning at least $500 in 5 days. So more than or equals to $500 here. But wait, what's S3? Now we can just sub in, no? 5D plus 50 more than or equal to 500. Okay, actually before that, is this sentence clear? At least this equation, inequality. Yeah. Can salary, you need it to be more than 500, more than or equal to 90% chance. Then now, can you just immediately use this and type in the GC?
Cannot.
Okay, how about if I do 1 minus PS3 less than or equal to 499? Can I type in the GC now? Like I try to make this the subject. Can I solve it? With S3? Why cannot? Can I just use binomial PDF straight away?
Cannot.
Why cannot?
Must sub in the S3
with the 5D plus 50. Okay, why do we need to do that? Is because if you try to key in, okay, here's one possible thing that you could do that is wrong. You try to solve for PS3. Then this will become -1, so negative 0.1 times -1 become positive. Yeah, less than equal. And then you try to key in the number of trials, the n and the p value and then the value 499. You will end up with a problem, which is that S3 here, how do we know that it is binomial? We don't. Even though it's 5 times of d. Okay, is there a theorem? I need to look it up. Is it still binomial if you take a linear combination? I don't think so. So it's safer if we don't try to think about that. Here, S3 is not binomial. All right. The only thing that's binomial here is D. So that's why you need to sub in. Can remember? Must still sub in the S3. Okay, good. So now we can just work with this guy. Substitute the S3 first straight away. So we get 5D plus 50 more than equal 500. Okay, then now we can zoom in, just focus on the algebra now. Plus 50 bring over becomes -50. Then you have to divide by a 5. Maybe I'll just write it down at the side. 5D will become more than or equals to 500 minus 50. So 5D will be more than equal to 450. So D will be more than or equal to 90. Divide by 5. No need to flip the sign because 5 is positive. Is that okay?
Yeah.
Okay, good. Then it's more than equals to 0.9. So in that case, what do you get now? D more than equal to 90 is just 1 minus of P of D less than equal to 89. Can?
Yeah.
Okay, good. Then this will be more than or equals to 0.9. Then after that, what do you get? You can just make this guy the subject. Just subtract 1, then times -1. Then you have to flip the direction of the inequality. Can? Can. Okay, then now that you have this, finally, you can just use the GC again. We can sub in the P%. Sub in the P over 100. So we're gonna use a GC now. Plot the graph of this guy versus P. Okay. So let me just show you. I think this, can we just call it a day for this one?
Yeah, sure.
I think it's a bit too long already. Yeah. Yeah, we need to call it a day. So last one. No, for this guy, the n value is 2000. Then the P value is what? Is it just P? No, it's P over 100 here. You see? P% because they requested for P%. So you need to put down X over 100. Then what is your X value? What is your X value?
Um, 89.
89, yes. Okay, less than equal 89, so it must be 89. Paste it, and then you need it to be less than or equal to 0.1. So maybe we can draw in, let me think. Maybe, should I just draw a second table? No, this one is a probability, so I will need to draw a graph. So draw in the other graph, 0.1. Then you draw second, sorry, not second. Just go to window. I need to set the X to be less than 1. Remember why? Because X is representing the
probability.
Yes, correct. Okay, so yeah, then change the Y max. Let's say you got 0.1. Maybe I can change it to 0.2. It will look a bit nicer. Then I'll draw the graph. It will take quite a while. Let me see if I can speed this up. Oh no, where's the graph?
Oh no.
Too small. Okay, did I let me think. Did I do something wrongly? I don't think so. Hold on. Oh, sorry. Yeah. This P, okay. Sorry, this one is P over 100. So actually, P is not less than 1. It's less than 100. This entire thing is probability. So this entire P over 100 is less than 1, which means that P will be less than 1 times 100.
Oh.
Yeah, so sorry, I forgot that. I should let it draw the graph. But here, the answer is really 5. So let's just change it to 10 to make a nicer graph. We will get, what will we get? Wow, it's slow. Super slow. Oh my goodness. Yay, finally it's drawn. Okay, then we can finally oh no. Oh no. What was I doing? Yes. So now that we have drawn the graph, we need to figure out what's the solution. So we need this probability, which is this blue color guy, to be less than or equal to 0.1, which is the red color guy. Less than or equal means above or below. You're less than or equal to 0.1. So you're less than the ceiling. So above or below?
Below.
Below. So that means that you want the blue graph to be below the red graph. So let's just find the intersection first. Blue, red, enter. Get the answer of okay, we got the answer 5 point, what is it? Let me just pause this. Okay, so the final answer will be 5.1003636. Oh, and this will actually require you to have P to be more than or equals. Okay. Right, because you want it to be below. So that's why you can have a least value of P, right? To be 5.103SF. Can you see? Maybe I zoom in. Does it work? Here. I think you can see now 5.10036. Okay, okay.
Yeah. Okay.
Yeah, then that's all for today. Let me just